All attendees are in listen-only mode.
Good evening, everyone. This is Sandeep Giri here. Can you hear me and see my screen? The screen should say, Welcome to Big Data and Hadoop introductory session. Use Q&A to communicate with the instructor. Can you see it? Great. Great. Hi, Nikun, Sunil, and Pradeep. So, for first 10 minutes, first of all, welcome to the session. In this session, we'll be discussing Big Data and Hadoop. This session will serve you as an overview on Big Data and Hadoop. Both. Hadoop architecture we'll be discussing in the second half, and in the first half we'll be discussing the overview of big data, what is big data, and related topics. All right. So before I begin, I would love to, for first 10 minutes, I would love to get a understanding of your backgrounds. So feel free to introduce yourself, your name, in which company do you work, and how many years of experience you have, and from which city are you logged in. So please feel free to introduce yourself via questions window. Hi Ashutosh. Hi Naidu. Naidu is from Bangalore. Hi Hafif. Hafif Sek. And Ashutosh works for Juniper Networks. Hi Hashir. Hashir is from Cochin. Great. Shakuntala Naidu is from Bangalore. Pradeep is having 7 years of experience on C, C++ on Unix. Excellent. Excellent, Pradeep. You will have be able to correlate with what we are talking about very closely. And Shakuntala Naidu is a software engineer and she's working with Thomson Reuters. Excellent, Shakuntala. Thomson Reuters is a great company. And hi, Kamal. Kamal is from Aditi Technologies, Bangalore. Great, great, Kamal. Hi, Manoj. Okay, Manoj is my classmate from IIT Roorkee 2002 batch, and he enjoys learning new technology. Okay, great. Murli, hi Murli. Murli is from Southern California, Los Angeles area. Great, great to have such a diverse set of audience from various locations. And hi Nikunj. Okay, Nikunj is also from Juniper Networks. Excellent. Ashutosh is having 10 plus years of experience and is from Bangalore, mainly working with excellent Ashutosh. Excellent. Okay. And feel free to drop me an email. I would love to understand what kind of open source technologies you have been working with. And welcome Murli. Murli is from Bangalore with 10 plus years of experience and works with Narus Networks. Excellent. Okay. Great. We have Prithvi from Vizag. Great, great. And we have Mais who is working on his own startup, Mojoy, from Bangalore, mainly UI developer, curious to excellent, excellent. So we have a lot of entrepreneurs every time in my talk. There are at least 2 to 3 entrepreneurs who are building their own companies and they want to understand the basics. So Mais, any of you, even if you are not interested in the full course, this course should serve you as a basic overview and should serve you the purpose of identifying whether such kind of course will be helpful for you or not. Okay. Hi Shilpa. Shilpa is from Bangalore itself. Great. And is from my items analytics. Excellent. Analytics is a great hot area these days. Hi Mohsin. Mohsin is from Bangalore and I'm working with Nivea solution. Hi Gorinath is from Belgium, engineering student. Belgium. Excellent. Is it Belgaum or Belgium? It's a spelling mistake. But it's great to have a very great set of audience here. Hi Prasanna. Prasanna is working in Bangalore. Great. Again, Sunil is in Cognizant, Bangalore, 12 plus years of experience. Great, great Sunil. And Apaya is from Bangalore, working for AIG, 8 plus years of experience in domain of analytics. Excellent, excellent Apaya. This course will really be helpful for you because probably big data analytics is the next thing. I mean, the next logical step for you. Hi Sweta. Sweta is working in Oracle Bangalore for 1.2 years and has completed MTech from IIT Bombay. Welcome Sweta, and I'm sure you will enjoy the class. Excellent. So Shakuntala is from .NET technology background, but all of these technologies, actually all of these topics would apply to everyone. And we have Sudhir. Sudhir is working with Canadian Aircraft Electronics and has 7 plus years of experience. Wow. So we have a great set of audience. We have Murli. Murli is from Sybase. Excellent. 14 plus years of experience. So Murli, you will be able to identify more with the databases and you will be your learning curve will be very good. Karthik is from Chennai, working for Algorithm Informatics as technical analyst. Wow, great, great, Karthik. So, so Venkat is from Bangalore and he has no experience, having 14 plus years of experience in Oracle DBA. Excellent, Venkat. I'm sure you will enjoy this. Okay. And you will be able to correlate and quickly learn all of these technologies because you have got a great experience. And Prasanna is working in Bangalore. Great. He is an engineering manager at EMC. Great, 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 Ashutosh. And okay, EMC is a great company. And yeah, okay. Murli has experience in investment banks in US. Great, great. Wow. So I have got so many more to respond to. Don't worry. Okay. So feel free to, if you have any doubts after this class, feel free to drop me an email. Okay. And the quick way to get the response is by writing to reach us at nobigdata.com. And if you have a technology query, if you have course related query, you can write to reach us at nobigdata.com. And nevertheless, none of our email will go unreplied. All right. So, and my personal email ID is sandeep at nobigdata.com. Okay. Wow. So we have got a great. So, firstly, the best way to interact with the instructor is via question and answer session, question and answer way. You type your question. I will try to answer as quickly as possible. If you are not happy with my answer, feel free to drop that message quickly. And in case the question is going beyond this session, I will respond to you via email, and for that I'll have to either take down your question on a paper, or you drop me an email and I'll respond to your question. Okay. So so in case your question is not answered within satisfactory limit here, you please drop me a message over email. All right. Wow. Okay. So Fasi is from Bangalore, is looking for job change, and has been working as an IT recruiter into software for 3 years. Great, great. So we have got a great set of audience. Fasi, welcome to the session. And yes, I may not be able to introduce all of you, but trust me, I will basically form a separate online group where all of you can connect together. And later on, maybe you can introduce yourself to each other. Okay. Because of the time constraints, I am moving ahead with the session. All right. I'm extremely sorry for other people who I have not been able to introduce, but uh, I mean, I would love to, go through these questions again. At the end of session, I go through all of your introductions again and try to understand all my audience. Right? So now I would love to start because there are around there are 55 people, 53 people in the session. Okay, which means that in total there are 51 people, 51 candidates. Okay, and so it'll be a little difficult for me to introduce everyone. So I'm moving on now. Okay. So let me before introducing what I am and what I'm going to teach, I'm a little bit of introduction about No Big Data. No Big Data is a company which I started around uh, 4 months back, 5 months back actually, on the 1st of April, and it sounded like an April Fool on the first day, but it has turned out a very great company for lots of people. So at No Big Data, our primary concern is training various giving training on various technologies related to big data. All right. We do training and consulting. So consulting is secondary, but training is our primary. In consulting, we help organizations to into big data analytics and and then build a great interaction between our candidates and the industry. All right. So the first thing we promote is asking a lot of questions during our sessions. Even if you ask the same question multiple times, I make sure that we answer your question, and I make sure that you understand what a concept is. Okay. And second is that we provide you the lifetime access of the content. We make a recording of all of these sessions and upload it at a central place. And all the learning material, everything, including quizzes and the whole learning plan, is available into your learning management system, and that is available for lifelong. Okay. Other than that, we provide you a cluster access. What does it mean by cluster access? Because since we give the training into a technologies which are big data based, big data by default means that it would require multiple computers. So it requires a cluster to do anything on big data. If you are doing big data on a single machine, it doesn't make any sense at all. All right. Therefore, Therefore, we have provided a big cluster for all our candidates so that they can experiment. No learning is complete or no learning is possible without experimentation by yourself. So we make this experimentation and learning very, very fast by providing you access to a cluster having multiple nodes. Cluster as in it has multiple computers. You don't have to install anything on your desktop or laptop or office computer or home computer. It is completely your choice, although we provide a complete detail on how to install on laptop, but we also provide you cluster access for which you don't need to install anything, and you can access all our cluster and understand how does a cluster work. Okay. And all the tools, technologies, everything, the whole stack is installed. Whether you are learning MongoDB, Hadoop, Apache Spark, everything is installed on the cluster. Okay. That has been one of the biggest steps we have taken, and that differentiates us from all other people into the same domain. Okay. We provide you, as I told you, that we also run a consulting with various organizations. So organizations, if they wish to do something in the big data, they generally ask us or me individually, and then I delegate that project and connect the organizations with our candidates for their real life project. In case any of my candidates or any of the team is not able to finish the project, then I take it up at my own. All right. So basically, what we are trying to do is, at the end of all the sessions, I form the teams of 2 or 3 people together. Okay. And it is up to you also. You might say that this person I want to form the team with. And then we give a real life project. Or so in most of the cases, what people do is people come up with their own project. I provide a resource, our cluster on which you can download the data, experiment a lot. So those kind of things are possible on our cluster. Okay. So real life project comes either from industry or from our any of the future product development, or it can even come from your own side. You might like to build something which you are planning, and you have convinced some of the teammates over here that this is a great idea, why don't we work together. So this also works like a small tiny uh, incubation, where you find other people having your similar thoughts. Okay. So that in case you plan to build, you can build. Some of my candidates from New York, they have formed up basically a small group, and they are building really cool idea. Okay. So that is the differentiation I'm bringing in. Okay. Okay. So someone is okay. Now, and rest is like, we provide you a socio pro visibility. At the end of session, we provide you certificate, recommendation, and in a general way to lift up your general profile. And in case you want it, we even help you with the mock interviews. Okay. If that happens on person to person basis. All right. So that is all about no big data. All right. Now let's talk a bit about what is about myself. I did my graduation from IIT Roorkee in 2002, and after that I joined a company called DE Shaw. DE Shaw used to run 10,000 nodes cluster at that time. All right. So we did not call it big data. We used to call it distributed programming. All right. So I was working on those clusters to do a lot of stuff which required to finish in couple of minutes, instead of, say for example, if I run my program, it used to take around 15 hours, but when we ran on a cluster, it used to finish in couple of minutes. Okay. So that was the magic of cluster, and we were doing it a lot during that time. After that, I founded a company called Tbits Global, which was basically a document management system. And I ran it for 5.5 years, and close to, you can say, 6 years. And after that, I joined InMobi and Amazon for a very brief period of time, where I again worked on, in InMobi, I was churning a data of close to 200 terabytes to build a very context sensitive recommender. Okay. And it was one of the interesting projects which I did in a very short span of time. Along with that, in during those 6 months, I did a lot of high throughput services for InMobi, and then I joined Amazon, where we were taking care of the detail page, Amazon's detail page, and built a high throughput service similar to Apache Storm, for which I came to know that it's similar to Apache Storm at a later point of time when we had built it. And that kind of system for Amazon from bottom up. So, and after that, in April 2014, I left. 31st March, I left Amazon and then founded knowbigdata.com. So this is about me. So most of my life has been into handling a very huge data and running on distributed systems. All right. So this is about me. In today's session, we are going to discuss what exactly is big data. I have realized that 99% of the people are very confused about big data. Okay. And because various people, because of their vested interest, have a tendency to confuse developers and everybody about the big data and its use case. So I'll try to clear up the myths, bust the myths, and will be very simple in my approach describing big data. And then in the second half, I'm going to deep dive into Hadoop architecture. In case you are just looking for an overview, you are an SDM or you are from the management background, this session should be more than sufficient. Even if you are a TPM, TPM is a technical program manager, or non-technical product manager. I mean, there are product managers who are non-technical. This session should be more or less sufficient for you understanding the basics of Hadoop. Okay, so stick around for 3 hours. So the session might extend a bit beyond 11:30 because of the 10 minutes went into introduction. All right, so do not worry about it. In case it's not covered today, we'll cover it in the session 2 again. So don't worry about it. Okay, now let's jump in. So let me ask you, what exactly does big data mean to you? Before I answering the question, let me ask you guys, so what does big data mean to you? Huge data. That's a good point. Hu- So, I mean, how huge do you do when we talk about data from multiple sources? Yes, but data from multiple sources was there before in relational databases also. Collection of unstructured data. Yes, Satish, it could be unstructured as well as structured. Excellent, Dubey. And yeah, large garbage of data. Okay. No, it's not really garbage of data. Gaurinath's point is it's not garbage of data. It's a data which people used to think that it's garbage, but it's no longer a garbage. Right, right. Right. So Nikunj is saying, okay, multiple type of data. Nikunj is saying that big data mean handle the many datas and manipulate it like Facebook and Google data. Good. Multi-type of data. Nice. Volume is too large to be handled by traditional. Excellent point. Prasad. Okay. So Narayan has a good answer. He says data, not a drop to use until processed. We could say data, and not a byte to use until processed properly. Okay. Okay. Too much variety, volume, and yeah. Okay. So some of you have a good enough idea about what is big data. All right. Karthik has a good point. Sudhir has a good point. All right. Mohini has a good point. Summer has a good point. Excellent. Excellent. Venkat has a point. Excellent. So, yeah, some of you have really answered well, saying data which cannot be processed by traditional tools. So, I will just a very simple way we can say big data means data of very big size. Now, People will ask you like, how big a size? Is it terabyte? Is it petabyte? Or is it, how big is it? And what does it mean by cannot process with the usual tool? Okay. Aren't we processing with a single computer? Are we building a newer computer? Are we building a newer operating system? So what does it mean by usual tools? Can't we use existing systems to process data? Okay. So, and then third one is distributed architecture needed. All right. So the most suitable answer, in my opinion and in my understanding, is any data, any data for processing or the storage of which requires distributed architecture. Okay. Whether it's structured or unstructured. Okay. So the general attribute or of big data is huge size, cannot process with usual tools. It can be structured or unstructured. But the most crucial point which actually define big data is you require distributed architecture. You require distributed architecture. That is the most important point. Even if you require two computers at the same time to process a data, we call it, it is a big data. All right. If your single computer is not able to suffice it, it is called big data. That is the single common point in all big data problems or in all big data analysis. You require multiple computers to solve your problem. And that's exactly the definition of your big data. All right. And that is what the definition we will consider, and all the tools which we are going to discuss when we are talking about Hadoop course, where all the courses no big data is going to take up, all of those courses, whether it's MongoDB, anything, it is related to the distributed architecture, meaning more than one computer needed at the same time to process your data. Okay. And these computers should be connected and should be coordinating with each other. So basically, any data processing or the storage problem that requires a distributed architecture, that requires multiple computers, is a big data problem. Okay. Now, the, now if you say to if you go somewhere for the interview and you say that any you give my answer, any problem which requires distributed architecture is big data problem, they might not be satisfied, they might be looking for this answer. All right. So what does this answer say? That this is basically a sort of IBM's answer. IBM has done a lot of literature on all of these big data technologies. They say that volume, velocity, and these are the four characteristics of big data. Big data should have a big volume, should have, or if the volume is not there, it has to have the high velocity. All right. So when we talk about volume, volume is data at rest. Data at rest, meaning we already have a huge data in our data store, or we at the end of day we'll have a huge data. So that is the volume which we are talking about. Like for example, at the end of day, when we talk about big data is something like when Boeing 737 per flight, it accumulates around 240 terabyte of data. Facebook accumulates around minimum of 500 terabyte of data. All right. And terabyte is a huge number. Then velocity. Velocity is high velocity, as in, say for example, you are running a simple tool which is basically your website counter, and lots of people are using your counter, and it is saving the updating a counter at a central place. Now, even though there are millions of requests per day, The data accumulated is just 1 million integers or 1 million numbers, which is a huge, which is small storage. Okay, which means you can say that uh, 24 million numbers, all right, 24 MB you can say easily. So although the storage is small in such cases, the velocity is too high. And to handle that velocity, you might require more than one computers. Okay. Or to handle that volume, you will require a lot of computers simultaneously. All right. Now, third attribute of big data is variety. Variety as in your data can be in the voice form, video form, maps, or all there are zillions of formats in which your data can be lying. And you should be able to handle all of this data. Whether this data is having high velocity or high volume or many kind of variety is these are the basically four attributes of big data. Right? Now the fourth one is your veracity. Okay, veracity as in the date. This is one new V introduced. These are four V's they call it. Earlier they were three V's, and maybe next year IBM comes up with one more V, and we have five V's and then six V's, and I don't know how many. So they introduced one more V in their definition called veracity, the data in doubt. So when you say that this is looks like unstructured data, but I'm not sure that is it is it really needed to be stored? Don't we have, is it a derivative data? We might have to drop it, and still we are storing it for time being, before till the analysis of this data. So that data is data in veracity. So maybe we might have to delete this data completely tomorrow. Okay, but still we store it just to make it doubly sure that this data is really useless. So until then this data is counted as as a big data, or this can be one of the attributes of the big data. But just remember that these this definition of big data for the sake of interviews. So Divakar is asking, any idea and rough figures for WhatsApp? I have no idea about WhatsApp's figures. Okay, and I might do basically homework, but I haven't gone through their numbers. But I'm not sure if they're storing your data centrally. Okay, or maybe they're storing. So that was the question from Divakar. Can you guys see the questions window here? So what is the maximum size you have heard so far? I have heard so far biggest is like few exabytes of data which Google is storing. Okay. If you follow Google on their blog. Okay. Okay. So which means so you can't see the questions window. That means I'll have to repeat the questions. All right. Is veracity critical for the definition of big data? Veracity is an attribute of small data also. That's a very good point, Prasad. And that is why I say that most of these definitions are definition for the sake of definitions. Okay. So this is a definition by IBM, and my the biggest attribute or the single most attribute you can say is any data for storage or processing of which you require multiple computers, then it's a big data. Okay, so this is just for the sake of verbiage, all right, that we are taking, and you have pointed out a very good point. That's exactly my thinking also. So Deepak's question is, do they store flight data, for how long and why? So Deepak, That's a very good point, and that's probably most of the managers in this world should be asking. All right. So long back, people did not care about storing the data, right? And that's a very important point. Okay. So till Amazon and Google's of the world came up with the usage of the historical data, nobody was really inclined to store any data, right? Until Google came up with this idea of Gmail and other stuff, where they started churning the emails of people to figure out various patterns and even automatically label them and train the machines to learn from that data. People were not inclined to store any data. But flight data, or any data for that matter, might look very useless today, but will be very useful tomorrow. Like, for example, the solution I had built for InmoBee, which used to give recommendations, was based on historical Apache request. You understand? So web server receives a lot of requests from users, and based on that log, that web log, I created a recommender which used to provide people on on what are the what are the recommendations for various people. Okay, so there is a lot of data magic that is possible, and uh, earlier, because of the storage was far more costly. Okay, storage were far more costly. People used to delete the data. And now storage is less costlier than the user's information and the magic you can do on top of it, but to provide various kinds of services to the user. So if you think about flight data, you can actually come up with lot of usage patterns of the flight data, to an extent that you can figure out when is the flight going to break down, just based on the past few data sets. So it is actually possible, and there are many such use case. Okay. Okay. So Srinivas is saying my volume is not consistent. Yeah. So basically there might be some fluctuations with the webinar. So you might not hear everything clearly. So I'm sorry for that. In case you are not able to hear, or you are not able to see anything on the screen, try reconnecting. And in case you get disconnected and you're not able to connect again, try to uh, restart the browser and disconnect your I mean relog in. Okay. So Shilpa is saying that she wants to know what kind of processing is done using this. So I'll come back to that very quickly. Don't worry about it. So I'll go into the details. Does the customer preferences over a period of time on a particular website involve big data? Yes, absolutely, Prashant. And that is probably, that's Prashant's question, that does the customer's preference over period of time on a particular website also involve big data? So after a point in time, when you have hundreds of customers visiting you every minute or every hour, this data, their what they visited, where they clicked, where was their mouse pointer, and what is their general pattern, what objects they are visiting frequently. So all of this preference matter, or what kind of various kinds of settings they have done. Okay, so all of this comes to a point that this data becomes so useful, as you can see in case of Amazon. In case of Amazon, they immediate, as soon as you visit some product, and then after a point of time they figure out a pattern, and that becomes actually a very good experience for the end user also. Okay, because once we have figured out your customers behavior, you will not irritate them, you will instead provide them useful information. Alright? And this is a very big data problem, and half of half of the people are actually working on this. All right, because this is one set of data which gets generated very fast and which is very, very useful and immediate impact on the customers and on the business directly. So Mohini is saying we have multiple DB servers. That means it's a big data. So if it's a single data set which is being managed by multiple machine, then it is definitely a big data, right? It's just that you have figured out your ways of dividing the data and you are struggling every day to manage that data. Okay. And it is still big data. If you have already devised your own mechanisms to divide and distribute data onto multiple machines, it is still big data. And you are doing a great job. Till now, in which field they applied this big data and why? Okay. So this question is till now so I'll come back to that maybe in few slides later. Okay. Does big data process media like video and audio too? So big data does not do any process. Big data is the data and big is a adjective to the data. Okay. So big data doesn't do, but there are lots of big data tools which allow you to process media, and media processing like audio or video was already there before even all of these tools came in. It is just that all of these tools assist you in executing your usual audio video tools on top of the big data, okay, using multiple computers. So say you are enhancing your video or you are modifying your video or compressing a very large set of video, so you can execute the same process across multiple nodes, and that is how it helps you. All right, now, okay, in case of inconsistencies, we tend to delete the data. What is the use case for veracity? Good point, Ashutosh. So, in case of inconsistencies, yeah. So basically, we are very, very sure. The moment we are 100% sure that, hey, this data is inconsistent anyway, so there's no point in keeping this data. Okay. So that is not the use case. So till the point you are not sure, you had just a doubt, like this data may be inconsistent. All right, may be inconsistent. All right. So till that point, it's called veracity until you prove it to be inconsistent. Is a tweet a data in doubt and where okay, so basically a tweet cannot be I mean right away cannot be categorized into a veracity, okay, because tweet is a data which is going to be useful. Okay, it is not a derived data from elsewhere. It is a actual data, right? Okay, thank you, Murli. Murli is in US and is able to hear me loud and clear, so that clears my doubt. So my network speed is good. Right. So Sudhir's question is, are they not able to achieve their requirements with the current architecture by adding different servers? Not really. Not really. I can tell you for sure this part. Earlier, people were devising their own solution to distributed architectures, and but most of us, because I have also done a enterprise kind of solutions, and most of the solutions work generally on a single systems, and we used to buy a bigger servers, all right, because that was the psychology of most of the enterprises. So Manjunath, yes, I will be a little faster. Great. So Gaurinath is saying, can a client server architecture is, yep, because client server architecture is an architecture that is true for any kind of software you build, whether it's big data solutions, big data tools, or something. Big data is just data. Okay, big data is just data. Do not confuse it with big data tools or big data solutions. All right. So very quick question. So first one, the moment anybody answers it, I will quickly move to the next. How many bytes in a petabyte? Very quickly, just to see whether you're listening to me. So how many bytes are there in the petabytes? 10,000 terabytes. Are you sure, Mohini? 10 to the power 5, 10 into 5, no. And Venkat is saying 1024 terabyte. Excellent. And okay, great. Most of you have done pretty well. So, okay. So I'm talking to a very good audience. All right. Okay. So in essence, 10 to the power 15, most of you have answered well. Great. And the easier way to remember these kilobyte, megabyte, gigabyte, terabyte byte is by that they are multiples of 1000, 1024. Okay. Kilo, mega, giga, tera, peta, exa, zeta, iota. All right. So that is a quick way to remember these. And I mean, instead of every time, thinking about how much is it, you will become very fluent as you handle big data. All right. And to get a sense of big data, you should actually go through the Amazon's big data sets. If you go to Google and search for Amazon big data sets, you will see a lots of kinds of big data available as of today in the public domain. All right. To get more feeling of how big the data is. Now, let me talk about the graph of the data storage. All right. So this is standard image where couple of agencies have done this. There's a agency called Hilbert and Lopez who have done plotted this graph. It basically shows that in 1986, the digital data, the lower part of this graph, you see the gray part is digital storage, and the upper part, which is colored one, is an analog storage. All right. So basically, in 1986, the digital data was zero point zero 0.02 exabytes. All right, and analog was 2.6 exabyte. Now, in 2007, the data reached to 280 exabytes. And an exabyte is how many zeros does an exabyte has? 18 zeros, all right? Which means 2.8 into 10 to the power 20, which means 20 zeros after 3. So digital data suddenly exploded in 2002, the moment the digital age started. And this is very important. Okay. Now, why did it become so? Why did the data suddenly started growing, or why it became important to store data, and why do we need to discuss it now? Because there are multiple sources such as smartphones, which keep on producing a lot of data. As we are talking, I'm getting a lot of messages on my phone. I have got a call records, and I keep on taking pictures all the time, and then keep on typing messages all the time. And all of this together is basically, and on WhatsApp I have lots of messages coming in, various forwards. So there are in many ways we are generating data through smartphone. So smartphone came up in 2002. All right. And then the network became really cheap to establish, and it became possible to store connect, I mean, various sensors, various devices talking to each other, sending information, even without you attending to it. Okay, even without you knowing about it, lots of devices keep on talking to each other, storing all the communication. And then, of course, the social network. Social network is one big deal which happened, and which is probably one of the biggest sources of big data. It can be YouTube, Facebook, Twitter, Flickr, Google Plus, everything. Okay, so these are the reasons why we realize that there's so much of data, and I mean, we need require better tools. And on top of it, Moore's law failed. How many of you know what is Moore's law? Anybody? Any single answer will do. Okay, so nobody. So basically, before this whole era of big data started, we used to, as soon as we got little more data and our tools are not able to process it, so what we used to do is we used to upgrade our hardware. We had this common excuse that every 6 months our hardware is going to upgrade. So the rate at which the hardware was going increasing or improving was better than the data which was accumulating in organizations. Okay, and Moore's law said that the processor will become twice faster every 6 months, and that was true for quite some time. Okay, that was true for probably 10 15 years, or maybe more than that. Right. So yeah, thank you, Manjunath. So every not 5 years, it was actually 6 months. So therefore Moore's law actually failed in 2008, where the bottleneck became the data bus, which transfers the data from processor to the RAM. And therefore, even if you improve the processor further, it will not be doing any faster processing, because the bottleneck is the data bus. So that's the reason why Moore's law failed, and hence it was no longer an excuse of increasing the hardware capacity, as opposed to building better tools which could handle larger sets of data. Okay, so increasing vertically, increasing the data, increasing the processor was costlier than, or more difficult than using two processors parallelly in two computers. All right, I'll come back to that in details. Right. Yeah, thank you, Srinivas. Yes, it says about density of transistors, and which basically uh, you know become the processing speed in general. So Srinivas is right in that. Cool. So when we talk about any big data problem, there are basically, when we say that, we are not able to, this single computer is not able to handle my processing, or my requirement, my problem, my big data problem is not being handled by a computer. What becomes the bottleneck? Or in other words, when we say that when we say that, what is it that solves your problem? Okay, somebody has raised a hand. Yes, Fasi, you had any question? Fasi, you have raised your hand. Okay, so when we talk about that, I mean, we require a distributed architecture because our single computer is becoming a bottleneck. What is it that becomes the bottleneck? The answer is any of these four components. First one is CPU. Okay, but that doesn't mean that CPU becomes the bottleneck first. The first bottleneck probably comes from the RAM. The RAM size. So your computer is made up of various components, and the primary components are processor, which does the main computing, which does the basically the brain and the heart of the computer, and RAM is where it stores the data intermittently for processing. Okay, and because in RAM the read and write speed is far faster than the disk, because in RAM it is a random access and it can jump to anywhere. We'll come back to that again. And third resource that becomes a bottleneck is the disk and the speed. Disk disk size and the speed. So for example, the usual tape drive has got a huge disk space, but the speed is slow. So it might not be great for some use case. But SSD, which has come up recently, it has got a little smaller size, but is as great at speed. Okay. So some so your disk space, which is a permanent storage where you store your files, where you store data, can also become the bottleneck, either with respect to the speed or the size of the data you are trying to store. All right. So when we talk about the storage means the the how much data can we store and at what rate we can write and read this data, right? And the fourth one, which almost all of us will ignore, is the network bandwidth. Okay, so when we are trying to fit our data and we're trying to solve our problem, one of these things will start becoming a bottleneck, right? Like for example, when Wikipedia guys launched, so the first thing that became a bottleneck was the RAM. It was never the processor or the disk size. The whole Wikipedia comes in around 100 GB. Still, whole plain text, a single hard disk is sufficient. All right. So disk is never a problem for them, but RAM is the problem for them. Processor is not a problem. So 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 any of these four basic building blocks become the bottleneck. Okay, we'll talk about all these fours and when do they become bottleneck as we go ahead. All right. So and by adding more computers, we are not doubling the capacity, we are doing more than that, because by adding one more computer we are adding more processor, we are adding more RAM, we are adding more disk size, we are adding a network. All right, network speed. So so it's not always, when we add more computers to the network, it doesn't multiply by 2, it multiplies by more than that, depending on how well you utilize these resources. Okay, so keep that in mind and we will talk about it in more details. Yes, Divyanshu and Fasi, you have a question? So basically these are the four building blocks of when we say a computer, or when we say, hey, my single computer is not able to handle my problem. Okay, and what does it mean by it can't handle? Either of these four or more than one of these four building blocks is becoming a problem for you. All right, it can be CPU, you are not able to process faster. Say for example, you are trying to do a uh, you know do a lot of processing of your data. Okay, say for example, I'll talk about processing in detail again. Okay, so the next is that before we go ahead, I want to work with you guys. Right, so Murli is saying, what about the overhead you are going to have because of the distribution? Okay, so that is exactly that is exactly the role your tools will play. And if your data and if you build your tools correctly, you can reduce the overhead by quite some amount, and the overhead of distribution is there, and therefore it won't be, when you add one more computers, it won't become four times, or you can say 2 into 2 into 2 into 2, which is 16 times. It won't become 16 times. Okay, it will be somewhere between 2 to 16, based on how well you build your tools. Okay. Okay, so before I move forward, So first problem, there are basically two problems when we deal about big data. First problem is how do we store it? And second problem is how do we process it? Okay. These are the basic two problems which we deal in the industry. First is how do I process it? How do I store it? I have got 100 petabyte of data, but we have got only 1 terabyte of hard disks. How do we store it? First problem. Second is I have got 100 petabyte of data. How do I find out as simple as things like, what is the demand in the next month? All right. So these are the various simple questions. So first problem which the whole world tried to solve is how do I store big data? And and I am posing to you that, say you are one of such guys. Yes, Gaurinath. Garna saying that use cloud, that's pretty easy. But here, you are the guy who is supposed to build a cloud. Okay. Now imagine this: you live in a society where hundreds of residents are there, or say 5,000 residents are there, and all of you had a meeting and said, "Hey, you want to build a movie center in the complex, and we want to store all our movies at that place." All right. So you realize that after doing a little bit of computation that you have got 100 terabyte of 100, you need 100 terabyte of disk space. So how would you build such a system? Okay. And this having 100 terabyte of data is probably not a big deal. If all of you, we have say 73 people in the team. We have 73 people in this session. All right. So if all these 73 people if all these 73 people try to basically if all these 73 people put together their movies, probably it will cross 100 terabyte of data. Okay. So 100 terabyte, you got 100 terabyte of storage, you require 100 terabyte of storage. How would you store it? You have got to build 100 terabyte of storage. How would you build such kind of storage? Anybody quick? Distributed storage. So Srinivas is a little step ahead. So he's saying that go ahead about distribution. So can you just give me a simple example? How do you build a distributed storage? Okay, Ashutosh is saying, assuming we have disk and you are asking no disk issues, storage deduplication, which one is more than, less than, least? I did not get your question. Assuming we have disk and you are asking no disk issues, storage, which one is more? Okay, okay. I'm not able to. So if you could rephrase it a bit, probably I can answer. Okay. So Sweta is saying divide the data among different computers, keep a central place to record of it like a zookeeper, keep replication for the backup. Great, great. So you look like you have already gone through the whole architectures. So I'm glad and thank you. So I mean that's what we are trying to build. Okay. Use 100 into 1 terabyte of disk. Thank you, Prabhjot. Yes. And distributed NAS or SAN. Okay. Murli, we will come back to that. And probably what we are trying to build is probably NAS or SAN or RAID right now. And I will go into the details on why that would not suffice. Share our computers. Okay. Okay. And structured distribution. Okay. Distributed around cluster, good. Online sharing, basically tier of the data. Okay. Provisions and deduplication and compression, good, good. Thank you, Nikunj. Divide it into manageable chunks and store separately, great. Put it to different PCs and connect those PCs in a network, excellent, Sudhir. Okay, so probably that is what we are going to discuss. And okay. So, Deepak, the thing is that we realized that 100 terabyte is the data which is after removing the redundant data. All right. And let's say that even after compression, you cannot go beyond 100 terabyte. That is the deal. Okay. Excellent. Athiraz is saying that how does torrent work? Great, great. So we have got really great answers from the audience, and probably this is a very great set of audience. So first set of answers say that build a distributed architecture, which is what is the final solution we'll talk about. Second is build a kind of NAS or RAID based systems, and which is very similar to the other set of answers, which are saying that, hey, take 100 hard disk or take 100 computers containing 100 hard disk, each of 1 terabyte, and then you connect them together. In case of a RAID is something like a backup of a disk. Okay, backup of a disk, as in case one disk fails, there is a backup there. Okay, and RAID works very well to protect you against disk failures. Out of all the problems which you have in network, the biggest problem is disk failure. All right. So the average life of a disk probably is 3 to 5 years, and some of the disk actually fail in first year itself. Right. So Rackspace published a very great statistics of their hard disks. So RAID works very well to protect you against against the disk failure, because anything you write to a disk, it gets quickly replicated to another disk on the same computer. So that is the RAID. And what you do while you're building an NAS or SAN. NAS or NAS means networked attached storage, or SAN means storage area network. And in a very rudimentary way, if I have to be very, you know, very oversimplified in my explanation, then this is what we do. Take 100 terabytes of drives, 100 drives each of 1 terabyte, put them into 100 computers, connect these computers over a network, and map these drives onto, say, 101th computer, which has got these 100 drives as subfolders into a single folder, and tell all these people in your you know mm, apartment, this is my computer where all of these hard drives are mounted. You can watch your movies from these folders. It is as simple as that. Right. Now, right. Thank you, Sunil. Probably that is what we are going to do finally. So I'll not be a spoiler at this moment of time. I'll try to explain why we are doing what we are doing. Okay. Why we are doing HDFS. All right. I'm taking a bottom up approach. So this is how. And in case of a RAID systems, what we used to do is, on each computer containing 1 terabyte of data, we have one or two more hard disks containing the backup of your 1 terabyte. All right. So you will have actual storage will be 200 terabyte, while 100 terabyte will be just to keep the backup. All right. So do you see any challenges with this approach? Do you see any challenges of this approach? You have got 100 1 terabyte drives, and you put these 100 1 terabyte drives into, say, 100 computers, and you connect them over the network. All right. And then mounted all of these hard drives into one place. Okay. And whenever people click on a particular folder, they directly get connected to that computer and start accessing the data from that one. So do you see any challenge here? Murli is saying file system, OS, buffer cache, etc. Excellent, Murli. Thank you. So yes, so there will be lot of problems. Right. So all of these computers have to be online. Yes, Gaurinath. When the person is accessing via 100th. Yes. Anyway, we would require them to be online no matter what solution are we going to use. All right. Network can be bottleneck pretty fast. Yes, Ashutosh. So network, yes, will become a bottleneck. I take that point. Very good point, actually. Then, because this point, what Ashutosh is raising, is probably most ignored one. Okay, I'll talk to that again. Why? Building networks for these 100 is a challenge. Thank you, Ashutosh. But probably you can use multiple switches and a chain of similar switches connecting together, forming a tree structure, and then you can connect them. Maybe you can have, say, 10 nodes on each computer, and then which means 10 routers. 10 plus, you can say, 11 routers. 11 routers should suffice. Processing 100 drives. Yes, yes, that will be a challenge. Takes more power. Yes, it will consume more power. That's a very good point, Gaurinath. So Sweta has a very good point. We are dedicated two disks for a particular partition. It has higher chance of failure that both disks will fail. That's a very good point. Yes, that can happen. Say, yeah, I'll come back to that. Yeah. Network design will be a problem. Network will not have the bandwidth to handle the data flow. So network design will not be much of a difficult issue because we had been doing all of this for years. 100 connecting 100 computers in a network is not a big deal. Network will not have the bandwidth to handle the data flow. Yes, that will be a problem. Overhead in accessing them, yes. What if any one of the hard drives fail? 100th drive can fail, yes. But for that you have RAID, all right. You have already in place the build the mechanism. Even network, then a problem will come. Yes. So yeah, Murli, thank you for answering on my basic behalf. He's saying that even network, even if data is distributed, then will become a problem. Yes, because network here we are assuming that setting up network is good idea. Setting up network is possible. No matter what solution we use, we need to set up a network. All right, no matter what architecture you use. So network has to be good in any case. This failure, network bandwidth will become a issue. There is one particular case I'll talk about. Right. How to reach right system. Thank you, Venkat. Excellent, Mohammed. Will not be knowing what data is where in which drive. Can be a challenge to map. Thank you. That's a very big challenge. And even if we build conventions, and we will have to keep on moving the conventions. Many users may access the same disk at the same time. Very good point, Sudhir. This is again lots of us will ignore this point. All right, right, excellent. So most of you have actually already answered. So let me you know put forward whatever questions you have raised in a very quick summary. First, what about failures and backups? We did a backup, as we said, that in the addition to my answer, I appended saying let's build the RAID. Okay, so we have built and we have defended against the hard disk failure, but there are network failure, operating system failure, and then computer failure, as Murli has put it. So there could be multiple such failures. All right, and And how do we defend against it? A computer can fail in the sense that uh, I have been to a scenario where network cable was one of the biggest deal, right? So network cable failure is quite common. So an operating system also, at various point of time. So it's not only the hard disk. Hard disk has got the highest possibility of failure, but that can be handled very well by having RAID. But there are other kind of challenges we are talking about. So in case a computer goes down and you are processing a data, you have to go back and try to figure out how to turn it on. In case there's a system crash or something, you'll have to take out the hard disk, put it in another computer, and then start working. And that becomes impossible scenario at lot of circumstances. Okay. Now, how do we defend against such kind of failure? Any node or any system can become unavailable, right? So first is that problem. Second is, say we said that we'll create 100 subfolders, each mapping to one computer. Computer 1, computer 2, computer 3, and so on. Or we can say drive 1, drive 2, drive 3, and till drive 100. How are we how are we going to decide which movie is going onto which folder? Say today we decide upon that, okay, let's dedicate these folder on this. Later point of time you realize that most of the movies are starting with the the, as English movies are. Okay. Or the Braveheart, the Matrix, there are all movies start with the word called the, and hence the the computer systems, you need to reallot more systems to the alphabet called the, because you built a scheme against movie names saying all the movies starting with A will go to server 1 to 10, all the movies from this to this, and so on. Now there is a huge challenge over here. So as you move on, there are high chances that these files may not fit into one system. Maybe most of the movies in particular alphabet are Blu-ray, 80 GB hard disk, 80 GB space required, and in those cases, your schema will fail more often than you have expected. Okay, your schema will fail miserably. Also, there are higher chances that your schema has been on over design, and most of the sections you had considered, that drive 1 to drive 10, are allocated to movies starting with A, and hence most of your space is empty in case of A while overfilled in case of T. All right. So therefore it is very very difficult to distribute the data uniformly using a manual technique, or using this technique where we divide the files in this manner. Then is it the best value for money? 1 terabyte may not be the cheapest available per GB as of today. Maybe 500 GB is there, but is it value for money? We have taken 1 terabyte of hard disk. Or tomorrow when we plan to design it, we said, okay, we'll take only 2 terabyte of disk. Second is, uh, we all might be having redundant hard disks lying at our home, or there are a lot of second-hand hard drives available which are performing pretty good. So can we make use of that? And that's the first thing. Probably Google did great, because what they did was, they were building the search engine, they bought the old hard disks from the whole college to store their whole World Wide Web data. So are we utilizing our resources correctly? Is it the best value for money? Fourth point, which almost all of us ignore, but today, at least 3-4 people had raised this point. Tomorrow we have got, say, a new movie, all right, and everybody in the complex wants to watch the same movie, and that movie is stored on a single computer, which means that computer is going to be overloaded very badly. All right. And therefore their computer will fail more often than you might think. So this is when there is a load increasing, can you handle that kind of scenario? Of course, this the structure we made does not, because everything starting first, it's starting with the network. So all the connections coming to that computer will will block badly. The one which is already transferring the data might also get slowed down, and eventually that system will be no longer accessible, and none of the people is able to watch that particular movie. How do we build such kind of system then? That's the question, which has great failovers and backups, which will distribute the data uniformly and properly. And also one more thing, that say you have got one, so you decided that we'll buy small or big hard disk. Okay. And you have got a 80 GB hard disk, and you now there is a movie which is 81 GB in size. How are you going to store it? That just you know derails all our plans of dividing the data dividing the data based on their names, and creating, and this division of data is generally called sharding, sharding. Okay. So how, so this sharding of the data, sharding, dividing data into parts, is is not uniform the way we have done it. And and the way we're trying to do is does not solve a problem in many cases, and this is how we generally built our storage networks. Then what is the solution? And this is exactly the way we built a network in 2002 at Disha. I mean, a couple of engineers did, but then we realized that the way we are doing is not great, and we actually did a lot of things in a HDFS way, but not really, I mean, exactly the way HDFS is done, but similar to that one a bit. All right. Now, to solve these kind of challenges, people build a file system called Hadoop file system. We'll dive. So now, if you're convinced about that the fact that we require a storage solution, then we should be reading something on the lines of HDFS. In very A paragraph of description is that in HDFS, when we try to store the file, all it does is it splits the file into small pieces and then distribute these pieces all over the network. Also, it keeps a copy of each piece on a remote different server, on a different server altogether, so that in case one piece get lost, there is a copy of the piece available in the network, and the moment, so it keeps on re-replicating also. The moment one computer goes down containing a particular replica of the data, it quickly re-replicates and creates its copy. So that is how an HDFS work. If somebody has to force me to answer in a sentence, so this is my answer. All right. So you divide the data into small pieces, distribute it all the network, and when people ask for the data or ask for an individual piece, return that data. It's as simple as that. All right. So this is the first problem of handling big data, called storage, and the how it has been done is using HDFS. Okay. Now the next challenge is, okay, now we talked about storage. So do you have any problems, questions related to storage? If you have questions related to HDFS, I will answer them in this in the later point of time. Okay. So Divakar has got a question: is the division of the data between on certain business value on HDFS? So mostly the division of the data is completely sequential on HDFS. Okay. you take a movie and sequentially cut it and then divide it. Okay, there is no business logic involved. We don't say that all the servers in India should have this portion of the data. No. On HDFS, it is mostly decided, I mean, it is mostly the call of the name node. Okay, I will talk about in detail in second half what is name node, how do we divide it. All right. Earlier in the manual sharding, whenever you used to divide the data manually, we generally take care of the business value. For I mean, we used to divide the data on the various kinds of attributes of data. But now, when we deal with HDFS, we don't do that. The only point which governs the only point which controls HDFS is how many copies of data do you want? Do you want, is this data very important business wise? If yes, create a replica more than two or more than three. All right. But by default, it stores each piece is copied three times by default. Okay. A replica of three. So Murli's question is, does it divide evenly or based on blocks of a particular size? So basically, the default way of dividing the data is into 64 MB in the default one. In Cloudera HDFS, it is 128 MB. So by default, it divides the data into 64 MB sizes. All right. Was I able to answer your question, Murli? Great. Thank you, Murli. Now, moving on. So the next problem we are going to discuss in detail is processing. Now, in processing, when we talk about processing, there are billions of processing problem out there. A simple conditional statement saying if A is greater than B, then do this. Or when you say ask your uh, you know you know your friend that if the teacher has come today, then inform me, SMS me. That step of conditional statement itself is a processing statement. It requires an intelligence to handle it, or it requires a processing power to handle such statement. Or problem as complicated as this, that given this graph of cities, or given this graph of the paths in a city, these are the roads, these are the various kinds of locations, find the best path from one place to another is also a processing step. Or given the data of all the customers, give me give me per customer total sales happened in last 2 years. So any of such problems is called processing, wherever you have to read the data and then do some sort of computation on top of it, and then uh, you know display it or store it somewhere. So that is a processing. And in today we are going to discuss a problem called sorting. Sorting means ordering a data by a certain sequence, by ascending or descending order of any value. Okay, that is called sorting, ordering the data by a certain attribute, right? So most of the problems starting with, say, let's take a case of group by. Group by can very well be solved if you have ordered the data by the field which you are grouping by. When you are saying group by each customer, right? So it involves ordering the data by that particular field and then giving you the results. Then before group by, let's also talk about, say, select star from the table where my column value equals this. There I'm filtering the data based on certain attribute, right? And that requires that if you go sequentially, order by order, you pick one order, check whether if this is meeting your criteria or not, and keep on moving. It is extremely slow. And to make it faster, what you do is you order this data by a certain by the attribute you're looking for. Say you're looking for Sandeep in a huge database table, and what you will do is compare the name column with Sandeep. And if you go sequentially from top to bottom, it is going to take a huge time. And if you, let's say, prepare a dictionary or prepare an index, name against the row number, okay, which means you will have to take all these names from this column and then order them in a certain manner, order them in ascending order, so that you can quickly find it. The way you remember in a dictionary, if I ask you, hey, can you give me the meaning of this word, you can quickly find it, right? Because it's ordered already. So lot of searching problems can be easily solved by sorting the data. And therefore, sorting is probably the most important problem to solve when it comes to processing. There are billions of problems related to processing, but most of the problems can be made easier to solve or can be entirely solved by using order sorting as a tool. All right. So sorting is a very important aspect. So before, all right. Okay. So yeah. So I leave you with one this problem. Like, say you have to order 10 billion names of people or 10 billion names of something, which is each name is around 100 characters long, and you have to order this data. How much time do you think it is going to take for a computer which is of 1 gigahertz processor and 2 GB RAM? Okay. Here, why I am talking about such a low level things and such a crude examples is because I want you to feel how do we process the data. Okay. And when we talk about processing the data, talking about solving the whole world's problem or the hunger problem of the world probably starts with sorting the data. Okay. So here I ask you a simple question, and before that I'll just go through some more questions people are asking. So while distributing, does it take any near or far logic? Thank you, Murli, for asking this question. So I will come back to this point. This is a very fine point. So when we store the data onto HDFS, the smartest thing it does is first copy it stores very close to the user, while the other two copies it stores far from the user. Okay, so that's an important aspect. And how does it compute near or far is based on how you have defined your network topology. Okay, so probably that will, I'll go into the details. So when you build your cluster of HDFS, you tell that how is your network organized. Okay, in the form of a tree. And when you ask a node to store your data, it does is that first copy of the data will be very close to you, and all the two copies of the data will be far from you. So that is one logic it takes care of. Now, Monoj's question is there a chance that all three copies of data divided data, a small chunk of A, on the same server? No. It makes sure that each chunk, okay, each chunk, so so when it divided a file into small chunk, it tries to replicate it into, say, a chunk is A1 and A2. So A will be stored on a machine and A1 and A2 will be always stored on different machines, because if we store on the same machine, it is no point at all. Okay. So it is not considered as replication if it's on the same node, but it's a very good question. Thank you. Okay. Gorinath is saying it is going to take 4 or 5 hours. I want to take a quick break of say 5 to 10 minutes. So you guys think about this problem. So Murli, it is a mostly like a tree. Okay, it's mostly like a tree when we structure our network. And yeah, So Sweta's question is interesting, and can somebody answer it? So this question is that I said two copies will be far from the user. Her question is, will these two copies which are far from the user are far from each other or not? So in fact they are far from each other also. So HDFS is a tree structure. That is a question of Murli. Okay. And so HDFS in general is sort of a peer-to-peer network. But when you define we call it a rack awareness. Okay, just to compute how far are two nodes is basically based on you defining each IP in each IP or host name in terms of a tree. Okay, A, A/B/D. Okay, so from that point of view, it looks like a tree structure. Okay, but it may be completely different. Yes, far from but connected. Of course, Gaurinath, thank you. Let's go for a break. Okay. Yeah. So Divakar, question, we are not able to see each other's questions. Okay, because of this restriction by webinar. I actually would have loved if you could see each other's question. Uh, if A1, A2 chunks failed by power some problem in the PC, what will be next? Okay. Okay. So, okay, this I think I should. Okay, so from Sudhir's question onwards, I will take a break from here. And in the meantime, all of you guys go through this question. Okay, go through, try to answer this problem. Okay, I will come back and answer all of your problems. Okay, so here is question for you. How much time does it take to order the data, which is 10 billion names, having 100 characters each on average? And the RAM is 2 GB. The RAM is 2 GB and processor is 1 gigahertz. How much time do you think it is going to take? Okay, let's take a break. I'll mute, but the screen will be visible to you. Hi guys, I'm back. Are you guys back? Okay. Okay. So, are you guys back? Fine. Let's start. Okay. So, Sudhir, are you back? I'm trying to answer your question. Great. So, Sudhir's question is if A1, A2 chunks, I mean, the computers which were having the chunk A1, A2. So, we divided, say, one big file into, say, 26 chunks. And we are giving names like A, B, C, and D, and so on, right? And now each portion, like A will have one more copy called A1 and other copy called A2. I'm just giving them names, okay? Just for the explanation purpose. So we divided a big file into A, B, C, and D. Now we picked up the first chunk. I mean, we as in when we say we as in the HDFS, it created a copy of A as A1 and A2. Okay. Now, what is and stored these A1 and A2 on different computers then where it's storing A. And these all three computers are far from each other. We will go into details how exactly they're stored. All right. So, and that will happen during probably second class. And so what Sudhir's question is, what if A1 and A2 chunks are failed by power or some other problem in the PC? What will be next? Then the basically your that particular chunk is inaccessible and HDFS will give an error, right? In these cases you generally try at least the probability of happening such a situation is very 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 small. Having all these three computers getting lost is very very small. Say one probability of one computer failure in a day is say 0.1%, and so is the second one and so is third one. So the probability of all three failing on the same day or on the same minute or on the same hour is very very small, very 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 small. 0.00001 sort of. All right. So if you multiply, because the probabilities will multiply in this case, so probability of failing all these three together will be probability of failing a1 multiplied by probability of failing a1 multiplied by probability of a2, and this will be very very small number. So such a situation arising is a very very rare incident. All right. So in this case, you might have to do the manual intervention and figure out how you can recover the data. Okay. Silpa's question is, since the nodes are far or near, how fast the process be? We will discuss in detail. So the overall idea about processing is that instead of bringing the data to the code, we take code to the data. Okay, that is one of the key aspects of big data tools. Most of them take the code to the data because code or the processing units, I mean the code which need to be processed is generally very small in size and there is a less of traffic involved. All right, therefore the code is taken to the data. So okay, so we have got good answers. And first one was from Gorinath. He says 4 to 5 hours. Excellent. And okay, and then we have again, yeah, thank you, Gorinath. Now, Ayush is saying 5 hours. Mohini is saying 4 to 5 hours of sorting. Excellent. And Deepak is saying 10 to 20, 12 minutes. Okay. And Murli is saying 8:36 seconds. Okay. Okay. Okay, so Divakar is saying that any reasons why we are not able to see each other members comment. So actually what is happening, Divakar, is since there are a lot of people who sign up in these free sessions, therefore we go for go to webinar kind of go to webinar instead of go to meeting. Okay, and in go to meeting, go to webinar, these guys are not allowing for some reason people seeing each other's question. Okay, I will also check the settings. Okay, I will also, actually already did a little bit of checking. Okay, but I'm not able to make it visible because if I make the questions visible to each other, it is actually beneficial to all of the people. And his next question is, will you be sharing this PPT to the members? Yes, I'll be sharing the PPT with the members. Okay, I'll dropping an email with the link to this video which is happening right now, as well as the link to the PPT I'll be sending to all of you. Okay. So nothing to worry, no need to take too many of notes. Just focus on the general questions which are arising in your mind. Okay. Just focus on that point and try to understand what I'm about to say. Don't worry about the this slides. I'll send it. All right. Right. So Sweta, yes, you are right. So it's 0.001 kind of probability. You probably are answering my probability question. Now, so Murli's question is interesting. So 1 terabyte, 64 kilobyte disk operation, 64 kilobyte sort of short time of algorithm. Okay. Ashutosh is saying 5 hours. Silpa is saying, how come this time everybody has got my answer like 5 hours? Okay. So when I was actually doing the computation, I realized that I did a computation, and some of you, the way you have answers, my all my computation said that it should be below 1 hour. Okay, it should be below 1 hour. And when I did a when I did a actual run, that time I realized that it is actually 5 hours, and I was surprised. Then I went back and did I realized where is the time going? So time is not going in actual processing of the data. Time, I mean processor, if I had a bigger RAM, if I had 1 terabyte RAM, it could have finished in couple of milliseconds. And the data could have been loaded into the RAM already. So why I ask this question? Because most of us think that computers is very fast, computers are very fast, and they can solve any problem or any iteration very very fast. Okay, but when it comes to big data, computers, even a 1 gigahertz processor is taking 5 hours of time even to do a basic computation such as ordering the data in ascending or descending order, is a basic thing like sorting the data, right? We do it day in day out. whole day, right? So even such a thing, I mean, we all have used Excels, and we all have used our SQL queries, where we just say select star from my table and order my data, and you have the data in few milliseconds, right? And you always think that, I mean, processing the data is really really fast. Okay, and therefore I asked this question. So it actually takes 5 hours of 5 hours of time. And why is it taking 5 hours of time? Is it has to read the data from disk. So the way I did this exercise was, I took a 1 terabyte of file. Okay, I divided into, say, close to 2 GB of size each. I had a little bigger RAM of 3 GB, 2 plus 1 GB. 1 GB I'm dedicating something else. I'm just giving, so probably 2 GB was available to me. Okay, so I divided my data into 2 GB 2 GB sizes, which means 500 pieces of 2 GB each. I sorted each of these pieces together using a command called sort, and I did all of this processing parallelly. So 2 GB has to be loaded into the RAM of the computer. Then the computer will order it using any of the algorithms, such as merge sort, and then I put it back into a disk, and did it all for all 500 pieces. All right. And once I have these 500 pieces ordered, I merge them together using a command called sort minus m of Unix, and merge them together. So basically, it is like divide and conquer. I divided a big file into small pieces, and then ordered them each one individually, and then merged them together. Okay, merging two sorted files or merging two sorted sets is far easier than ordering a bigger set. Okay, now imagine this: if you have two queues in which people are standing in the increasing order of their heights, you you can easily merge them together and form a single line, right? Think of when you go back, you think about it. You have got two lines in which people are standing in their increasing order of the height, and you are standing in front, and you are trying to your job is to merge them together. So it's pretty easy to merge them together, as compared to trying to order trying to order 20 people by increasing order of their heights. Okay, so you understand the divide and conquer part. So I divided my whole file into small pieces of 2 GB each, which can fit into my RAM, and then I ordered each of these portions and saved it back into the hard disk, and then I merged them together to form the output. Okay, so that is how I did my processing. So this is sorting the data is probably the biggest step. And the process I just described is what your MapReduce does. Okay. It divides the data. So as we discussed in the previous, slides, so our data is already divided and is stored on multiple nodes. If we have to sort it, we just have to tell all the nodes to order the data, right? And then we merging them together is not a big deal. Or if we are executing a processing, say we want to filter this data, we can send our logic to all these nodes which contain sections of your data. All right, which contain sections of your data. Your logic might be sorting this data, your logic might be filtering this data, it could be doing a lot of things, right? And this logic can go to all these machines which are running in parallel, and it will be executed simultaneously. All right. So we will come back to how to execute your logic when we are dealing with MapReduce in detail. So this sorting of the data is exactly the problem solved by MapReduce. All right. So what you do is you take your logic, try to convert it into a sorting problem, as I described earlier. Your The whole select query, whether you are looking by index or you are trying to filter the data, or can be converted into a sorting problem. Okay, and MapReduce exactly provides you a sorting or the execution of your logic, okay, by the way of sorting the data. We'll go into the details how does MapReduce do it. Okay, but in essence the biggest problem it solves is sorting of the data. If you remember when I said group by, group, whenever you say select star from my table, group by this, basically we we are trying to sort by that particular column whenever we say group by. Okay, and that's exactly the problem when it arises. If you have a big database containing few terabyte of data and try to group by on that, and if it's not sorted, you will go for a toss. Okay, and it's not actually possible using single node. If you have like 10 terabyte of data and try to order by a particular column, it might take few days. Okay, all right. Now, so this I got 5 hours when I tried to do it, but uh, 5 hours first of all is too much, right? You might want to order a data in say 10 minutes, and that's pretty much. Other is, in case data goes from 1 terabyte to 5 terabyte, okay, or let's say your data is same problem, I pose the same problem to you, okay, I say pose the say this problem to you with 2 terabyte of data. I'm only changing 2 terabyte here and 20 billion names or 20 characters each, 200 characters each. Okay, now how much time do you think it is going to take? Will it take will it take more than 5 hours or more than 10 hours, equal to 10 hours, less than 10 hours for 2 terabyte of data? For 2 terabyte of data, Gaurinath is saying it will take close to 7 hours. Anybody? Will it will be less than, for 2 terabyte of sorting, will it be less than 10 hours or more than 10 hours? 6 to 7 hours, less than 10 hours. Why do you think it will be less than 10 hours? Ashutosh, Mohini and Gaurinath? Why will it be less than 10 hours if you have 2 terabyte of data? More than 10 hours. Yes. So Ayush is saying that more than 10 hours. Yes, it will be more than 10 hours. Okay. Because when you increase the data to 2 terabyte, not only your processing has increased, it also has increased. First, the order in which, if you are basically your, the rate at the relation between the time taken to sorting itself is not proportional. Okay, itself is not proportional to the directly proportional to the data size. Okay, it is n log n. If you have n records, then the time taken to process this is proportional to n into log of n. All right, so first, that is not proportional. Second, other than processing step, you have to read the data from disk, load it into the memory, and disk becomes the bottleneck. Remember, disk will become the bottleneck because out of all the things, reading from disk is the slowest thing, and that will, so all of these factors combined will make it more than 10 hours. Okay, and it might become 20 hours, as Muhammad is saying. Okay, but I cannot say anything about it until I actually do it. Okay, so we need to do a bigger data sorting, and therefore no matter how much hardware you add, okay, you might increase the RAM. Let's say you increase the RAM to 20 GB. All right, the way we used to do in 80s, we might increase the RAM, but then processor will become a bottleneck. You increase the processor, now your hard disk speed will become the bottleneck, and all of these come at a cost. And after a certain point of time, you say that we don't have a better hard disk than this one. We can't handle this sort of data. Let's do one thing. We just consider only last week's data instead of considering the whole data. And that's how you compromise. That's how we used to compromise. And we might have to do all of this very, very often. Okay. Like at the time of the issue, I was doing an anti-money laundering. Okay. And I used to run a lot of data processing on a single node earlier. And it was taking around 14 hours of time on a single node, single computer, the server which was allotted to me. And we needed to do that every 2 hours. Now, how can we run something every 2 hours, which is taking 14 hours to run in one instance, right? So therefore, we might have to do it more often. So exactly this problem is solved by MapReduce. MapReduce tries to sort the data, and you, by the way of your code or by the way of your tools like PigHive and all those tools they have provided, you tell MapReduce on what parameters does it need to sort the data. All right, whether by name, by inverse of the name, by age, or what is it that Hadoop need to sort the data by. Okay, and after it has finished the sorting the data, what it needs to do, and you need to tell in the form of map and reduce logic. Okay, so you write your map reduce telling you write your map function telling Hadoop ki, this is my data, and on this parameter you need to sort this data. And then you write reduce function after you have sorted what to do with the data having the same key. Okay, the key on which it was sorted, you communicated the key while in your map logic, and in reduce you say that for each key this is what you need to do. Okay, so that is what the whole map reduce framework is. And map reduce framework again is based on a paper by the way HDFS is also based on a paper by Google. Map reduce is also based on a paper by Google. Okay, so most of the big data tools or the Hadoop infrastructure has come from Google and Amazon's paper. Okay, so basically in Google published a report in 2011. They were able to sort 10 petabyte of data in 6.5 hours. Okay, here it took me 5 hours to order the data on a single node. They ordered they sorted 10,000 times data in 6.5 hours. How? By using 8,000 computers parallelly. Okay. Okay. Great. Great. Thank you, Asuto. I mean, good that you understood what I mean to say. So, any questions at this point, or should I move on? So this was more about basically these are the two things on which the whole ecosystem is standing. One is storage, other is processing. In processing, we are talking about sorting only right now. All right. Excellent. Now, okay. So this was about what why the big data, why when we say that it is not possible to use the traditional tools, or why do we require distributed programming. I tried to prove that point by using these two basic examples in the previous two slides. One is storage, other is processing, right? That was my first attempt. Now the motivation, why do you need, or who is big data customers? And remember, these are not something future technology. Everybody is already doing it. I was working with Amazon, and I was also observing the other teams like our machine learning and this rating, I mean review recommendations. Okay, so we had been doing it for quite some time. All right, so let's talk about retailing. So we have something called recommendation engines. Recommendation engine is you know, fairly important concepts when it comes to retailing. Okay, it helps the users to find out what they might also require. Okay, what is it? What is, you basically increase the chances of a user discovering something which is useful to them. So recommendation engines are really very important things which happen to the whole industry. Now everybody is building recommendation engine, other than, I mean, almost everybody. Okay, now you can recommend them a good movie, you can recommend them the good product based on people similar to them. And how do we categorize this similarity? Based on their history. You visited same 5 products as Sandeep Giri. Okay, those same 5 products as Sandeep Giri has visited, and therefore your behavior in general is like Sandeep Giri. Therefore we can give recommendations to you which 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 are other than those 5 products. Okay, and similarly we can give recommendations to Sandeep Giri based on your behavior. And and that is basically what recommendation engine does. So recommendation engines are like, have you gone to Amazon website and seen the the product detail page, and where it says that you may also like this, people who bought this also bought that. So when I was building recommendation engine for InMobi, I was churning a data of 200 terabyte. Okay, 200 terabyte hues. Okay, so 200 terabyte is like how many zeros? 2 followed by 14 zeros, right? So and it's not unusual to get that kind of data. It's very normal. Now, second problem which we have with retailing or any of the web-based companies like Google, or even like mobile advertising companies such as InMobi and AdMob. So ad targeting, when the data is very small, sounds very simple. But when that data grows big, right? Think of this. Millions of people using mobile apps where each one is having one ad slot, right? And on the other side of the wire, there are thousands of candidates which are suitable to be displayed on these millions of machines. How do we display the data, display these ads? Which ads should go to which machines? And this should happen in a fraction of second, because in case you don't give it, you are basically wasting time, wasting that ad space. And therefore ad targeting is one of the games which need to be played really fast. So most of the patterns, most of the ad targeting, you try to pre-cache it, you try to figure out lots of kinds of patterns already in place, and then keep these ads prepared all the time. So ad targeting is one such area where lots of people are using. Then there is search quality. Most of us thought the search is dead. Okay, but search is a very important aspect. And trust me, 95% of the companies are not able to prepare a good search engine for their products. A search is required by probably every area. So say for example, when I say big data, search for big data, should it search for big space data, big without space, and in huge data, and how does it work? So there are various things that you could do for improving your search results. Like for Gmail, it does the crawling of the half of the internet and tries to figure out who are synonyms to each other, which words come together all the time. Okay, based on if you have twisted the word or you have done a mistyping somewhere, what kind of suggestions do I need to give? Okay, if you are searching for work, should I give the results for working, worked, as well as I mean something which is similar to work. Okay, so works, work, worked, working, all of these you need to give them the result. Like it is called stemming problem when it comes to search, these adding ses, ing, and and er on the worker, worked, works, working, and and all such derivations of the single word is basically stemming problem. So if you combine all of these things together, you will have to do a lot of churning upfront to figure out to give a best results. You might have to prepare a new kind of dictionary based on the data accumulated, but based on the context. Maybe the user is searching for a Hindi word. So all of these combined together makes a very very big case for a search quality for big data analysis. Okay, and this is a very common thing, probably everybody is doing it. Okay, like there's a company called Bloomreach nearby, and then there's a company called Unboxed. They provide searching techniques to various e-commerce companies who are not able to do by themselves. So it's already there, and they use all of these cloud technologies to do that. Sentiment analysis probably is a very overused word nowadays. So you go to, so all it does is basically you have a huge dictionary of negative and positive words. So that's I'm just talking about a very rudimentary sentiment analysis. And based on this huge list, you figure out that associated with your name, how many negative words are used, how many positive words are used. And you plot this graph over a period of time and then see how is sentiment changing? How is sentiments towards you or your product changing in the world? Okay, that is sentiment analysis. Like probably most of these these political campaigns, they every day noticed that when yesterday we launched a particular campaign, is are people talking more positive about me or more negative about me? In campaign of Obama or any of our Indian leaders campaign, this was exhaustively used. Okay, so all of these techniques like click fraud detection and abuse, and this is done very frequently based on certain behavioral pattern of the user, which we have plotted a graph based on history. So every time we detect a fraud and actually it's a fraud, then we have the history of the user in place, right? Similarly, similarly we have other users where the no fraud was detected, and based on it we can, you know, we prepare a lot of parameters related to a user, and then at the end of it we can clearly figure out a user of this pattern or this behavior is generally a fraud, and upfront we can stop him. Google does it a lot. So every time it figures out that people are clicking on your ad who are which is fraud, maybe my competitor is clicking on my ad, it does figure out a lot, and then it reimburse the money to the advertiser whose ads were clicked by a fraud guy, and it also penalizes the other person. Okay, and in telecommunications, I mean, these are the things which people are already using based on a lot of data. The data which we thought that it's useless and we should be deleting it, archiving it, or putting it away. Nowadays, people are able to successfully use the user behavior or a particular data to derive various kinds of insights, derive various kinds of useful uh, products out of it. Telecommunication, these are few examples. I have taken this example from the Hadoop implementers Cloudera website as well as Hottenworks. These are not my own cooked examples. These are people already using it. It is just that there are not enough engineers available in the industry who can utilize and derive a better results as of today. Okay, There are not many engineers, there are only few engineers. Okay, so there is a huge demand out there. There are these few examples. Okay, and here there are 11 common myths which I have seen. Okay, and out of it the most prominent one is it will be the future. No, it is the future, it is the present. Okay, it is the present, people are already using it. Okay, and the other common mistake is we have you know, it is only for few companies like like Google's, and it's not for us. That's a very very you know, bad, I mean bad way of thinking. It is because you are not accumulating the data, you are deleting or dropping the user related data. If you are doing any business, there are high chances that you are already in need of such data. Okay, already in need of a cloud, or of a cluster. It is just that you are not storing the data. You are just saying at one end you are saying you don't have any use case, and another you are when it comes to actual storage, you say that this data is useless, so I'm deleting it. Okay, and why you say useless? Because the cost of that storage is so high that you find the data useless than the storage. Okay, less costly than the storage. Okay, therefore it is very important to build this psyche that probably none of the data which you gather specifically from the user behavior is never useless, or none of the data accumulated by your sensors or automatically accumulated is not useless. You can always figure out new insights. It is just the limitation of our thought. Okay, does it make sense? Do we have any questions right now? So these are the 11 common myths. Okay, and here are few statistics from what I have gathered. Since I'll be sending you the slides, you can go ahead with the okay. EDW is enterprise data warehousing. All right, which means basically it will replace enterprise data warehousing. The answer is no. Data warehousing will be there for all your transactional data, because when you use distributed computing, it comes at a bit of cost, in the sense that it does not provide you a great way of handling the transactional data. So Vishnu is saying that the last myth is big data is about Hadoop. So most of us think that big data is only about Hadoop. It is not. Okay. There are more and more frameworks coming up every day to solve big data problem. Okay. Starting with things like MongoDB, and then Apache Spark. And there are, I mean, every second day new frameworks are coming, and okay, and there are already so many other. So big data is basically a problem which Hadoop is one such solution. Okay. So cloud and computing and big data are similar in a sense that for handling big data, you would require more than one nodes. And when you say more than one nodes, you end up having your own cloud, or you buy a cloud from existing vendors. Okay. So these terms, distributed programming, cloud computing, big data handling, okay, they are mostly synonyms to each other. So Tejman's question is, R programming is a part of big data. See, R programming existed even before data was big, right? So R is mostly about analyzing the data. Okay, analyzing the data. And R helps you even in case of big data because it can be executed in a distributed fashion. Okay. Which framework to start with to become big data developer? So out of all the frameworks, I probably recommend you to stick to Hadoop stack because it covers the most complete solution, including a NoSQL database, and therefore it gives you all sorts of clarity on concepts. It has a Hadoop ecosystem is built up of various kinds of tools, and therefore Hadoop is probably the most complete way of exploring the big data tools. So probably you need to probably the best tools to stick as of today is the Hadoop ecosystem. Are we going on Hadoop in this or some? Yeah, in the few next sessions, okay, we'll be going ahead with the Hadoop details, and installation will not be considered in detail. Okay, that will be taken into Hadoop separate session. Okay, not in this one. All right. For a startup company, is it better to buy a cloud-based solution or can it be set up its own cluster for handling big data? So Hasi's question is very, very good. We are also struggling with the same answer. And my call right now was to actually outsource it to other people, other companies. But uh, soon enough, we might be able to, we are actually computing which one to take. Till then, we have taken from a company called Digital Ocean, but they don't have. They have a great, uh, you know, great servers. They okay. So answer is that it is probably a better to hire a third party. It's better to hire a third party than managing your own servers. If your server, if you are able to maintain that network, okay. And so let's take a step back, okay. So when I was at InMobi, what we had done is we had actually set up two clusters, okay. One was using one we had taken from Amazon, and one we had set up in-house. In-house was for our own experimentation all the time, since we had to experiment a lot, and anything which we required in production, we moved it to Amazon. Okay, so whenever if it's production critical and you require it in production, probably it is better to move it to outside. If it is not production critical and it is for your own internal analysis in the same office, probably it's better to set up locally using commodity hardware. Hope Hazir I am able to answer your question. This is a very good question. What is difference between EDW and MDM and Hadoop? Thank you, Raju. This is a good question. So EDW is enterprise data warehousing, while MDM is master data management. Is that right, Raju? I'm not great with the data warehousing terminologies and Hadoop. So EDW or MDM, both the techniques or both the technology stack assumed data to be smaller, or it sliced the data into a smaller shape. Okay, but I mean, as well as it only kept the data ordered by some dimensions. Okay, which means the processing only on those dimensions were very fast. Okay, while and the data which we handled over there was in at most terabyte. I conducted a quick survey. Even the giants in the industry do not go beyond a terabyte using EDW. Okay, maybe 10 terabytes, nothing more than that. Okay, But here, when we talk about HDFS and all, they have been designed for petabytes of data, okay, exabytes of data in mind. So that is first difference. So but on the other part, EDW and MDM is very, very great when you have got a great relational data. All right. So one is good for relational data, other is good for huge data or big data. So what is the latest framework for big data problem? Latest framework is Apache Spark, which is doing good. Is MapReduce included within Hadoop? Yes. So they are the two basic structure. How different is Apache Spark compared to Hadoop? That is probably a very long answer, but and I will probably, how should I say? You drop me an email. I'll just send you two screenshot, and these will answer your question. Okay. I think most of the US corporations use AWS for prototyping proof of concept before they proceed further into. Yep. So that's also a good way to see most of the, not only the US corporations, but also even smaller companies, they actually use AWS for prototyping. So would be covering big data on low cost storage via Hadoop? Yes. In recent news, Apache Spark is 100 times faster than Hadoop. Is it so? Yes. So, I mean, Apache Spark comes at the speed, but and I will be covering Apache Spark, by the way, in these 10 sessions. Okay, there is one session devoted to Apache Spark. Okay, it is actually faster, but it comes at certain cost. It is effective. Most of the tools for big data are available on AWS. So yeah, Murli, it is actually little cost effective, but when you talk about reading and writing terabytes of data, it doesn't actually make much sense if you are just using it locally. It doesn't make much sense to put all of the computation to AWS. Okay, they will charge you a lot. If you don't believe me, ask some of the people who are using. Okay. Brahma Reddy's question is Apache versus Taze, which we can discuss it little later. Don't, I mean, maybe in other session, but I'll make a note of it and we'll drop your email. Okay, because this session is anyway going to get recorded, and these questions I'll go through again. So I'll answer you via email. Okay. So Raju's question is, does Spark overcome Hadoop in future? Okay. So that's a big question. So may or may not be. Okay. Spark comes at its own complexity, while Hadoop is still, you know, it's not, it's easy to mess up your Spark script by making it extremely slow, but it's not possible to mess up your Hadoop. Okay. What is the skill set required for the data scientist? Okay, that's another big deal. So data scientist is basically a combination of a big data guy plus analyst plus a lot more. Okay. Actually, to become a data scientist, you need to have a good idea about differentiating between signal and noise. Okay. You need to have a great idea about doing forecasting and doing predictive modeling. So along with that, probably one of the languages, either Python and or R, you should be knowing it. So those are the kind of things you should do, and you should be good at maths. So that is a role of the data scientist generally, and maybe it's my narrow view because I have met those kind of data scientists mostly. So Brahma, just drop me email. I'll make sure that I answer your question. All right. Now moving on. Before doing that, so basically Hadoop is, basically a frame. Most important point over here is that Hadoop is a framework to handle for reliable, scalable, and distributed computing. It's a suite of components. It's not a single component. Although we continue to think of it as a either HDFS or MapReduce, but it is not that way. It is started with MapReduce and HDFS, but it continues to be a general umbrella term. Okay. So the Hadoop keeps on adopting more and more components every day. Are there any future webinar for Hadoop in future? My last question, and from messing up you. So actually you can the future webinar next one is on the 13th night at the same time. Okay, because on the 13th the course is starting on 13th, so it is that time. All right. So Hadoop is basically a umbrella term to it's a suite of components, and those components should be scalable and related to distributed computing and should be reliable. That is the general agenda of any tools being adopted under the umbrella of Hadoop. Okay. So the core of Hadoop lies in two things. First one is HDFS, Hadoop Distributed File System. It stores multiple copies of file parts on multiple machines. This is the single small definition I could come up with. And MapReduce engine is execute your logic on multiple machines in parallel. All right, we'll go into the details very quickly. Now, let's talk about the architecture of Hadoop. What are the various components and what do they do? This should give you a fair amount of idea about various components. Here, I have missed out Apache Spark, which is equivalent to MapReduce here. If you divide this strip, MapReduce strip into two, one is MapReduce and then Apache Spark, then it's right. All right. So this is what an ecosystem looks like. At the heart of it, I mean, it doesn't look like a bottom, but this is basically the bottom. The Hadoop distributed file system. All of the components under the umbrella of Hadoop talk to HDFS. Okay, they can store the data to HDFS. They may or may not store, but they all can store. And HDFS provides service to all the components. And HDFS is an independent itself. Okay, so HDFS is something which everybody relies upon, and HDFS doesn't rely on any other components. Okay, so that is the base of the whole foundation. HDFS is what? A distributed file system in which we store the pieces of it automatically divides a big file into small chunks and stores them on different machines or on the same machine, and each piece is also replicated so that we have a and replicated onto another machine. So this is the main component. The second component on top of HDFS is your compute engine. Okay, compute engine is basically helps you do the computation on various different nodes. Same logic will be executed on multiple computers simultaneously to solve your problem. Okay. The third component in the Hadoop ecosystem, which is important, is a HBase. HBase is a NoSQL database, a database which runs on multiple nodes. Okay. Whenever we talk about NoSQL, think of it as a database which cannot provide you a relational database properties such as ACID properties of a transaction. Okay, the data is not have those relational constraints because it is distributed. Most of these databases fail badly to provide that kind of guarantees as your relational database does. So similar is HBase. HBase is a database which runs on multiple thousands of computers to store hundreds of billions of rows. Okay, hundreds of billions of rows by thousands of columns. or 10,000s of columns. So that kind of data HBase can store very happily. All right. Now let's move on. Now the next, these were the two foundation of the whole game. One was MapReduce, other was HDFS. HBase uses HDFS to store and uses MapReduce to do the computation, such as when you say group by, when you say order by, all of these things HBase delegates to MapReduce. Most of the processing HBase does is using MapReduce. Okay, that is why this box of HBase is lying inside the box of MapReduce. Okay. Okay. So Gaurinath's question before we move ahead is, what is yarn? Yarn is basically they rewrote MapReduce. Earlier the distributed computing only was possible using MapReduce paradigm. Okay, by creating maps and reduces. But I mean later on they divided the whole MapReduce into two parts. One is run any kind of code on any machine. Okay, and MapReduce is just one client of it. So the yarn is basically re-architecture of MapReduce, where yarn's duty is any logic you give it, it you can build similar systems like MapReduce. Okay, MapReduce, how does it do is you write two functions called, one is called map, other is called reduce. Map defines the keys for sorting, and then Hadoop sorts the data using that keys, and then reduce defines how to aggregate the data. Okay, so this was the pattern in MapReduce. But later on, people realized that MapReduce is not the only way to process the data. There are multiple other kinds of problems, such as you know processing a graph, processing other kind of data. So to do that kind of, to solve all kinds of problem, MapReduce was not really the only solution. I mean, really not a solution. Therefore, what they did was they splitted MapReduce into two parts. First, a, a general or generic compute engine or generic resource manager, they call it. Yet another resource negotiator. Okay, yarn. So they devised basically a basic framework which can be utilized by various systems such as MapReduce, as well as other systems like Apache Spark, to execute any code in the network. You don't have to write map and reduce only. There are other ways of solving the problems also. So that is why they divided the MapReduce into two parts. And that is what the yarn architecture is. Okay. I hope I am able to clear it. Yes, you can use R instead of Mahat for machine learning. But R has its own constraints. Basically, they are not competitor to each other. R and Mahat is not competitor to each other. While R is basically a programming language, complete programming language, while the Mahat is basically a library of various machine learning functions. So you always use both the things simultaneously. All right. So Mahat is basically a library of algorithms. The way we talked about sorting algorithm. Similarly, Mahat is a library of clustering algorithms, machine learning algorithms. Okay. While R is a proper programming language for data processing. Now, on top of it, there is a very important component called Hive. Hive lets you combine the data from various data sources. All right. Hive lets you combine the various data sources. So using Hive, see, and when we talked about HBase, HBase itself does not provide you select queries, order by this, group by this, all sorts of magic which was possible using SQL query was not possible with HBase kind of things. Okay, So whenever you have to churn the data, you have to write MapReduce, for example, right? Which is not a great way to solve a problem. And therefore, Hadoop provided a SQL interface. Using this SQL, you can query any database file as well as HBase, as well as you can use Hive to connect to other systems, even systems like MongoDB or other big database or enterprise data warehousing. And you can combine those tables with the tables stored in HBase to produce results. So out of the whole stack, Hive is very, very important to learn. For anybody who is coming from a DBA background, to be able to use Hive will not be a big deal, but knowing that there is something called Hive and this is how you use it is very important. All right, because it actually accepts a query language similar to Oracle. Okay, similar to Oracle. It has external table, partition tables, and everything. And under the hood, it stores data into those kind of models, which we already had. So Raju's question is from 2013. Hadoop is getting so popular, though it is released in 2008. Why did it so? Because it was maturing all the time. All right. People were building faith on it, building trust on it. People were very skeptical in the beginning. But I have used extensively Hadoop in 2011, and it was fairly popular in 2011 as well. So Raju is saying that my voice is not audible clearly. Is that correct? Are you guys able to hear me clearly? Just quick, even one answer is good enough. Great, great. So everybody is able to hear Raju. So I'm just dropping. Okay, okay. Now Hive is one such thing, and then people realize that to churn a data stored in HDFS or HBase, existing SQL solutions were not doing justice, were not fast enough, and therefore they came up with a language called Pig Latin. And to my surprise, most of the people are able to quickly learn Pig Latin. And I'm actually wondering, in the beginning when I started my classes, people were I was actually, skeptical that what's the point of learning a new language, it will have a big learning curve. And to my surprise, that most of us, it has got a very neat syntax as compared to SQL. And now I think, why didn't SQL do it? So Pig Latin is basically similar to SQL, but you can do a single query using multiple steps. Those people who come from a database background, they can think of Pig Latin as proper set-based operation. You do something, assign it to some symbolic table. Then you take that symbolic table, combine with some other data, and then you can do that magic all around. The only downside of Pig Latin is that it's a new language and people will take time, and already there are a lot of solutions built on top of SQL using SQL, and therefore it will not be wise to move those solutions to Pig Latin right now. But for anybody, it is a it has got a very small learning curve. You can learn it very, very quickly. And it is, to my surprise, when I ask people, I give my candidates a big problem, they they actually choose Pig Latin even though they have been DBA for quite some time. Okay, so Pig Latin is a very nice language which is quite efficient and done specifically because SQL was not designed bottom up for for churning the big data, but it is exactly like the overall objective is similar to SQL. Right? Now, the magician out here is your Mahat. Mahat provides you a library of very, very important machine learning algorithms. Okay, for example, I talked about recommendation, right? So recommendation, Mahat provides in a single line code. You say, this is my input data, generate the recommendation. All it wants is you to format the input data set. Okay, you provide it the input data set in the format it expects you, and it generates the results very nicely and very efficiently. Earlier, Mahat was used to run on top of Hadoop. Now, after the Yarn has on top of MapReduce, after Yarn has come up, it can run independently of MapReduce also and independent of Hadoop itself. So, Mahat is basically a general purpose machine learning libraries. Okay, it has got at least around 50-60 algorithms or more than that, which are really important and fast. So Brahma's question, was I able to explain to you now? Okay, okay. So Raju, is still my voice is not clear to you? Okay, Brahma's question. Okay, Brahma, I have answered your question already, I think. His question was related to difference between pig and hive. Mohini saying that select star from a table takes a lot of time. Is it true? Yes, for a small data, say you are churning a data of say 100 MB or say 1 GB. Still, you will feel it slow. But if you compare the select star from table on a data of a reasonable size, such as say 10 GB. Okay, 10 GB is not uncommon. And say select star from this table and filter on some value. Okay, and then see the difference. While your database will take forever, the if you have more cluster, it will be pretty fast actually. For small data, it will sound stupid to use any of this Hadoop. Actually, it will be stupid, and if you have very small data. Okay. And you will laugh at the whole stack saying, what's the point of having such a system? And that's exactly why I have set up the whole cluster to give you a feel that churning 20 GB or 40 GB data is actually possible. Okay. Because earlier, the moment you reach 10, 20 GB, it becomes a nightmare to manage. Was he able to answer your question, Mohini? So Nikunj is saying Hadoop is a cluster file system. Hadoop is not, but Hadoop distributed file system is basically a cluster file system. Basically, you can say it a cluster file system. Alright. I don't know about VXFS. I'm just making a note of it. So Nikunj is saying Hadoop is a cluster file system like VXFS. Okay. So Ayush is saying that do one need to learn all the components to work on big data? Actually, my point is that you should get acquainted with various components because most of things have been redone. Okay, and therefore it's not a difficult thing to go through the whole all of the components quickly and understand when to use what. Okay, despite of Mahat, R has an integration with Hadoop to do more statistics. How Mahat is different from a statistical language like R? Okay, Raju. So basically, statistical language like R, so there is no competition in my very opinion. You should be knowing R as well as Mahat. Mahat provides you a set of libraries, basically functions. Okay, you can utilize those. They're pre-built algorithms. There are only one or two clustering algorithms which R also provides. Okay, so you may use R for that, but you can use a combination of both the things. Okay, so Satish's question is, what is difference between HDFS and GPFS? GPFS, do you mean GFS, Google File System, Satish? Okay. So see, HDFS and Google File System both are exactly same because HDFS is written on a paper of Google File System. Okay. Okay. So Gaurinath's question is it ARC or R? Is it cap? It is basically capital R. I'm sending my answer to all. Okay. It is basically capital R. R as in R alphabet. Okay. So Raju's question is, does Mahat support data visualization? None of these support tools actually support visualization because by the time you get a time for visualization, your data, because you always visualize the data which is smaller. All right. So so Mahat does not provide you any visualization tool. All it does is take your data and generate the output data, which you can visualize in your favorite tool, or Mahat will store it on HDFS. You can query HDFS using any of your intelligence reporting tools, such as BIRT or Crystal Report. They have provided drivers for all of these. You can query it and represent it visually there, or you can use a library which latest, those libraries have come up with great visualization tools. Okay, so Mahat doesn't do that. So Nikun's question is, can we repair HDFS in case of corruption? Yes, it does provide you FSCK kind of parallel tool to FSCK. Okay, where is the zoo? So Bala Sundaram is asking a question. So what is zoo and what is related to zoo? Probably Bala Sundaram, you are talking about something called zookeeper. So Nikun's question is, if we can repair HDFS, the question comes here is, can we repair it online? Okay. Yes, you can repair it online, and it depends on what kind of damage is there. You can repair it online. It provides you that FSCK tool itself. Okay. Okay. So Tezwan's question is that R is used for geospatial visualization. I'm not sure about R because I'm not a very big expert on it. Okay. Okay. So that was Tezwan's question. So R is basically a general analytics language, which lot of which is used a lot in data analytics. So zookeeper, let me answer Bala Sundaram's question. Yeah. So basically, Zookeeper is one such tool which is basically for the coordination in thousands between thousands of servers. And instead of using local global variables the way we used to do between coordinations between two threads, okay, here we use a separate kind of systems to coordinate between thousands of servers which are trying to do something parallelly and want to talk to each other so that they don't contradict each other, or they can coordinate well. That is the role of a zookeeper. Zookeeper is a server. is there any hypervisor supported on HDFS? So it's the other way around. Okay. So hypervisor, I'm assuming that hypervisor is you're talking about the virtualization, right? So HDFS is supported on top of hypervisors. Okay. So basically HDFS and all of those, HDFS comes in any all of these VMware, OpenStack and all of those. I mean, you can install it. You can download a virtual machine of Hadoop from Cloudera or Hortonworks and then try it out. All right. So let me move on. Don't worry in case I'm getting a little bit late. Okay. So this is the general ecosystem, all right? And there is a workflow engine which runs all of these together parallelly. Okay. So Oozie basically executes your workflow engine in you know, some of your code in is in MapReduce format, other code is in written pig, and whatever output of the pig is coming out, you is feeding it to Mahoth is giving you analytics, and on top of it you are running Hive. So when you are solving a big data problem, you might end up using all of these together, or think of something like this. You have got unstructured data or structured data, which you are structured data. When to import structured data, you need a scoop kind of a solution, while to import unstructured data such as Apache log, you might use Flume. All right. And and to use all of these in coordination, right, you need a system where you can define output of this one goes to this one, and once this finishes, that one should be executed. Such kind of coordination, such kind of, workflow is executed using Oozie. Okay, Oozie is sort of a scheduler which does all of these things for you. All right. Instead of you sitting and waiting that once this finish then we'll run that and then all of that, it does it for you. Okay, so you write your script just like you guys have been writing the ant script, not ant script, basically a maven script, makefile script. Similar to ant script, you are basically, you will write a script for Oozie, or you will use a UI to generate that kind of a flow. Okay, finish this, then do that, and so on. All right. So that is more about Oozie. And then you have something called CLI, and the way you access all of these is through either command line or other programming language such as Java or Python. Okay, so this is the whole ecosystem. Here I have missed Apache Spark. Apache Spark is exactly parallel to MapReduce over here, that we will covering, and we will also covering what is Zookeeper, and we will also covering all of these Flume and Scoop and Mahout. All of these will be covering in this course. Okay, and probably there will be few more components which I have not mentioned over here. Okay, so Srinivas is asking what is Flume and Scoop? Are they the only way for structured analysis? Basically, they are the basic tools provided to you for import and export of data. Okay. If you have to import your data from file system and vice versa into HBase or into your relational database, then you can use Scoop. And in case you are importing data from, you have say thousands of Apache servers, you want to flow that data into HDFS. Say you are already running a web servers on into in your organization. All you want to do is collect the collect their log onto a central system. That is done using Flume. All right. So now basically I have run a bit out of time. Okay. So Oozie will not be running on all the servers. Oozie is basically a client which will run on a single machine, and then it will execute its task on multiple machines. That was Satish's question. Is Hadoop suitable for OLTP as it follows batch execution? OLTP stands for online transaction processing. So the straight away answer is no. Hadoop is not great for OLTP. You might use things like Apache Spark, or you might use a similar systems for that. Maybe, okay. So can you please define the hierarchy of these tools for solving the big data problem? Instead of understanding hierarchy, you should understand their role. And in the hierarchy, the base of the whole game is HDFS. On top of it stands MapReduce, and then stands HBase. But from correct standpoint, you should understand what you're trying to do, and accordingly, you will be able. Once you understand what each tool is capable of, then you will be able to take a call. Okay. So no, I'm not going to show the Hadoop installation online today. Okay. So Raju is saying, as we all know, there is a war between Hadoop and BI technology. What do you think in selecting one from your perspective and BI perspective? See, my point is there is no war at all. They both need to exist and coexist forever. There was a war when people thought that Hadoop is trying to take our space without understanding what is Hadoop. There was a war. But now people have understood that there is a particular use case when you should be using these technologies. And the result of Hadoop or all of the churning is actually generally stored in your standard BI tools. Okay. Therefore, if you look at any of the BI tool, they have started providing the connectors to Hadoop. Okay, so there is no such war. Nikunj, mean real-time installation and configuration scenario. So in this one, I'm not, because it is more like a development instance. But let me think about it. Probably this time I will be giving an installation examples. But other than that, lots of people do not want to do the installation. In those cases, basically what recommend is you take the virtual machine and start using it right away, as well as we give the login password to our cluster where you can log in. Okay. So probably I will see that probably we'll be providing the installation in this one. Okay. So Mohini's question is how long the session will go more. Actually just 10 more minutes and I should be done. Okay. So this was the architecture, and these are the let me explain to you what is HDFS cluster. Just look at the line below it. Okay. So there is something called admin node, and there is a data nodes. Okay. So the role of a admin node or name node is to basically to the admin node or name node does the job of main housekeeping. So, and data node's role is to actually store the data. Okay. So whenever you want to store the file, you ask the driver is HDFS driver goes to name node and asks, I want to store this file. Name node tells the driver back, hey, go to data node and store on these data nodes your file from 0th byte to n1 byte, from n1 byte to n2 byte, store it in some other node. So actual storage of the data, the role, the the actual storage is going to be done by data nodes, while name node will just do the bookkeeping. It will just make a note of from this file is being stored on this node from this byte to this byte, from this byte to this byte is on node 2, node 5 is storing this file. So that is the metadata it is going to store. Okay. So you go to name node and ask name node to store metadata. It delegates you to data nodes. Once you finish writing to data nodes, it goes back to name node. Most of us have the first question, why doesn't name node do for you? You ask name node to store the file and name node will store it on data nodes. But if name node does it for you, if name node starts doing it for you, the actual story, you went to the name node started doing actual writing, then name node will become the bottleneck. Okay, and that's what it avoids. So your client or your driver will go to, whenever you ask your HDFS driver saying, hey, I want to store this file, and the driver goes to name node saying, hey, this person wants to store this file. So name node gives a list of nodes and corresponding bytes. You go and store on these nodes your file. The first piece goes to this node, second piece goes to this node, and so on. So name node does not do any reading writing for you. It just gives you back that, okay, your file size is this much, that means I'm suggesting that you go to these people. All right, and once you are done, report to me so that I make a note of it. So that's the role of name node. Okay, so this is what I just explained. So that is the role of name node. And the moment name node goes down, there are secondary name node which keeps a snapshot of a little older data. Similarly, there is a backup nodes available nowadays which you can set up, which are basically mirror of the name node. In case name node goes down, what happens to your data? Now the next, similar to master slave architecture, as Ashutosh is saying. Okay, so hope I have answered Asutosh's question as well. So no other node, basically there is a secondary name node as well as a concept of backup node which has come up recently. So backup name nodes quickly takes up the place of the admin node. Okay. Also name node is generally a very big memory system. Okay. Most of the metadata is stored, all of the metadata is stored in the RAM. So you have to plan your system accordingly. Second is job tracker. So job tracker is basically a huge, when we talk about distributed programming. So Brahma Reddy is asking, are you going to take? Yes, I will take yarn architecture in detail later on, not today. All right. So I'll just go through when it comes to computation, what happens. So you as a client take your Java code or prepare the whole logic and go to job tracker and ask, hey, can you execute this program? And what job tracker is going to do is delegate it to something called task tracker. If you see this slide, if you see this slide, it has got under the black line, under the horizontal line, there is above this one, under the horizontal line there is SDFS, under above there is job tracker and task trackers. This is your map reduce engine. So similar to this one, job tracker only delegates work, it doesn't do any work, while task tracker does actual work. And task trackers are close to data nodes. Basically they are generally running on the same places. Okay, so you as a client go to job tracker. Hey, this is my code and I'm trying to churn this file. This is the input file for my program. I give the file name in HDFS. This is my file name and this is my program which is trying to process this file. Okay, you went to the job tracker. Now job tracker found out where all this file is located in the network. Okay, asking the name node, hey, which all nodes are storing this file? All right, now after it has done that, it will find out the task trackers who are executing, who are running either on the same node as your chunk or your piece, the file piece, the small chunk of your file, okay, or very close by. All right, and will delegate your processing, your map reduce logic only to those nodes. They will process that small data and return you the results in a consolidated format. Job tracker will read from there and store it back into HDFS. So all of these task trackers will basically store your results back into HDFS. Okay, so they read from HDFS, they write to HDFS. HDFS is what? File system by Hadoop. Okay. So task trackers are generally on the same as data nodes where the actual data is actually stored. So you sent a logic to be executed on each data node. It read the logic, wrote it back to the wrote the output of your map reduced logic onto the network. So that's a simple job tracker's job. Okay. So this is the simple the same thing which is done in details. Okay. And so that's pretty much from my side. Okay. In case you want more details, because I will be going through these more details on 13th probably. So you can attend again. Same session will be repeated that time. And so okay, those who are who have signed up for the whole course. Okay, and for them also this is the first class. Okay, they can log into the Cloud Labs here HDFS1, and there are multiple such nodes. So here this one is basically our hue. Okay, this is basically to monitor our the network, what is going on what nodes. Okay, to monitor the health of the network, shutting down services and all, and to actually do some sort of interaction with each service. Say for example you want to execute a pig script, or you want to execute your Uzi script. To do that you can use hue. This is hue. Okay, and this is Ambari. Okay. This is the admin console. Okay, admin console called Ambari. Okay, so this is what we use for our cluster. These are our clusters, access to the cluster, and you can also use SSH to our servers for uh, your running your exercises, and also go to my courses, click on the Hadoop course, and you will see the assignments. Please finish your quiz, as well as you should also keep a local instance, because local instance sometimes comes very quick and handy in case your network is down. Okay, so local instance is very simple. You just download the virtual machine as mentioned in the manual, and then you can start using it. Okay, and most of the assignment will be in the LMS itself, where you can see the assignment and complete it. All right, and also there is a Google group. I will send an email where you can join our Google group. This is only for those people who are attending our sessions, for full sessions. And further reading is there on Wikipedia. You can go through, and those who are not yet signed up for the full course, they can sign up for the full course, and second class onwards will be on 14th September. And the last session of the architecture will again be repeated in the second session, so that those who have missed a bit, they will be able to catch up. And and this is every Saturday, Sunday, 3 hours. It's a 30 hours course, 3 hours into 10 classes, and it is only 14,995 including all taxes. Now it has become more because it was offer earlier. Okay, and we provide the cluster and everything for all the students for your exercises, as well as your. Okay. What if there is no space left in name node to store metadata? In those cases, Raju, the name node, what it does is it does a computation. Okay, it does a calculation upfront that how much metadata it can store in the RAM. And if it cannot store more data into RAM, if your RAM is storage, the chunk size is going to grow big. It will not be 64 MB, it will be bigger, so that less metadata will be, it has to handle less metadata. Okay, so Guru Prasad's question is it going to be very large machine for storing name node? How does it affect scalability? So for name node, it is going to have the bigger RAM. Okay, but metadata, if you do the computation, a simple 8 GB RAM machine can actually handle exabytes of data very very easily. In case it is not, then I mean basically on the computation side it is going to handle easily. Is this a free course for Hadoop? Where to sign up? Actually, it's not a free course, so okay. I too need to earn my bread and butter. Okay. So basically, as I said here, it's like 15,995, 10 classes. Basically, 9 more classes to go. You have already completed one class. Okay. So that's it from my side, guys. If you have any question. So Gaurinath, I'll not be able to give you Cloud Labs access. That's only for the students. I was telling those people who have already signed up for full class. Okay. That ID is only for those candidates. Okay. So in case, so feel free to, get in touch or you can go to the website and go to our website, www.nobigdata.com and Hadoop, and then sign up for full course. Okay. Here you can go for enroll now and that's it. In case you are in US, you can go for the USD one and then enroll now. All right. All right. So yeah, for in USD it's $280, while in INR it is after discount 59.96. There are no additional charges. So feel free to get in touch and you can go ahead. Okay. Thank you guys and feel free to spread the word and it'll be great actually. I enjoy explaining most of the concepts. So this question is it a certified course? Actually, there is no single authority in Hadoop who gives the certification. There is Cloudera, there is Hortonworks, there is MapReduce, and there are people like us who basically, uh, you know, gives their own certificate, as well as we try to connect to the industry so that we are able to handle the consulting also. People who join the class, how long did you have? So generally it is 1.5 months for the cluster, but in case somebody is really, really interested, we can give them access for more than that. Okay. Will it be valid for companies? Your question. Basically, none of the companies as of today, when I went through their requirements, none of the companies is actually asking for certification. Okay. All they are doing is they keep their own test. In case you can qualify in that written test, online test, you can go ahead. Okay. So nobody is actually relying much on these certification tests these days. But nevertheless, our whole course is actually fine-tuned with Cloudera. Okay. Okay, great. Yes, yes, you can go for certification because the whole course is actually fine-tuned with the Cloudera one. Great. I'm happy, Mohani and Divaka, that you found this useful one. Once classes are done, will they still have access? Yes, generally for 1.5 months. But in case you are starting your personal project on big data and you have started working on an innovative product, the way one of my team is working in New York, they are basically building couple of solutions. So I extend my cloud access to them. So that's not much of a deal. Okay. So after the classes is done, you have 15 more days to access the cluster. But learning management system like recording all the presentations, all the quiz, and all the subjective questions and answer is available for lifelong. Okay. Thank you, Guru Prasad. Feel free to spread the word around, and I hope I was able to answer your questions. Okay, great, Sudhir. I'm actually glad that you learned a lot of things. So Raju's question is very good. He's asking what is the cluster size we use in the class. So as of today, we are good with around 12 nodes. Okay. And that's actually sufficient for most of the students. because we have around 100 plus students in the class. I mean, currently there are only 30 students. Yeah, 30 students. But past students are also using it. And I mean, 12 node Hadoop cluster is good enough for them. Okay. I'm happy, Sudhir, that you found it great. I'm actually glad. Okay. Murli, was I able to answer your question? Right. So, Murli, what we do is there are two kinds of problems which our people solve in the real-time project. One is they come up with their own problems, looking at the real data of the world. Say, for example, one of the candidate is actually, say, for example, one of the candidate is doing is he's trying to figure out the correlation between stock exchange and climate. So this kind of big data is available as of today. You have climate data, stock exchange data. So he's trying to figure that out and he's working on that. So one is this kind of real time, real world project, and other is that there is one guy who is trying to figure out the company called HP. They are trying to solve couple of problems using Hadoop. So one of their person is working with our interns and I'm working with them. Okay, so that's a kind of real world scenarios we cater to. But real world scenarios generally don't encapsulate all of these tools which we discussed. Okay, they'll only focus on one or two tools, whatever works for them. Okay, okay. So, okay, I am happy that you liked my patience and you really had patience too. That's Gorinath's point. Okay, great. Okay. Thank you guys. I'm really happy that you found it really useful and informative. And I try my best to explain the things, and I sometimes may not be, but I try my best. So Murli's question is, how do you make a difference with your competitors? Why will I choose yours against others who do the similar teaching? Okay, my simple point is that first, um, I come from a background which none of the instructors are right now. Okay. Second, I try my best to help out my candidates, even people with no prior experience in coding has been able to do successfully. If you do not believe me, you go through the profile of people who have written reviews about my course. If you go to www.knowbigdata.com and then go to Facebook, search for No Big Data and read our reviews. Okay, all of the candidates so far have written 5 out of 5. Okay, which actually proves that my classes are pretty successful. So those people who are really serious about learning, they will not probably go to some trainer who has no hands-on experience. Okay, so that's the difference I'm trying to make. Other difference I'm trying to make, I'm considering students not as students, but they may be partner in my further research into the domain. I have pinpointed couple of students, couple of people who are really good. So that's another difference which I'm trying to make. Okay. So Muhammad is saying that we provide a referral bonus, which yes, we provide a referral bonus of 10% to both the people who you are referring as well as the you if you are referring somebody. But provided you yourself has uh, you are a student basically. Only then. Okay. So we provide 10% bonus only if you are our students. Otherwise, no. Okay. But if you are referring somebody, they will get 10% anyway, even if you are not a student. Okay. Hope you got my point. So in case you are our student, you will get a 10% bonus, a 10% referral bonus, and uh, and anybody who are referring, they will get 10% bonus. In case you are not a student, then you would not get referral bonus, but they will get 10% discount. So you must have got a URL saying that you can give the discount. You can refer to your friends. Just give that URL to your friends. One more, we are we going to use AWS EC2 for running? No, actually, because there's not much of a difference in running your EC2 jobs. Okay, in running your EC2 jobs on AWS, I have not planned for AWS separately. Instead, what I will do is I will keep a separate class. The way what I have done is, people who are trying to connect MongoDB and Hadoop, I have prepared a separate video for them for free. They can use that one. It's on our YouTube channel. Similarly, for smaller tasks such as running your Hadoop jobs, I will be I'll be creating a separate video. Okay, so all those people who have attended ours, then we can do that. Okay. What are the distributions like Cloudera, Hortonworks, Map are you? So actually, I have decided to go ahead with Hortonworks because Cloudera was not really as smooth. I tried all three, and after that, we decided that we will be going ahead with Cloudera, Hortonworks. Okay, so we are using Hortonworks system, Hortonworks distribution. Murli's question is, I don't want to be developer, but only Hadoop administrator. Will your course help me in this goal? The answer is no, because this course is actually staged for people from r- databases background who plan to become a data architect, or who plan to further move on to become data scientist. Okay, Hadoop administration course, we are launching it separately. Okay, and it will be, maybe bundled with this one. Those people who are attending this one, that course might be at very low cost for them. Okay, so that is a separate course. So Mohammad's question is, what is the schedule of second to 10th training? Second class is going to be on 14th. Okay, second class is going to be on 14th, and and so on. So every Saturday, Sunday. So th- third class will be on 20th, fourth will be on 21st, and so on. Okay, and you can see the detail here also. So here you can see it is on 14th. All right. So, okay, what kind of proof of concepts we'll be doing in the class? So we'll be taking a simple examples on the usage of each tool, and we'll walk through from start to end. Okay. Say for example, for a zookeeper, we have a good example. For using Mahat, we have a good example. For using HDFS from start till end, we have a good example. Hive, we have a good example in place. Yes, we have a YouTube videos for on okay. So Murli's question is, do we have YouTube videos on Hadoop administration? Right now we don't. Okay. So right now we don't have, but we'll soon have. Okay, for the Hadoop administration one. So Raju's point is Hadoop suitable for freshers? My answer is, in case you do not have a prior experience with the database, a simple SQL, you should have a little bit of idea about databases, little bit idea about command line on Unix, or little bit idea about at least command line on Windows, as well as you should have at least somewhere down the line you must have done a programming. Okay, so this course may not be very very you know very suitable for those people who do not have the idea on these three topics. Okay, so I will recommend that in case you do not have a background on these three topics, I would recommend that you should not go ahead with this course. Okay, because all throughout the way today, if you were able to understand today's session, then you should be able to sail through the whole 10 sessions and will be able to understand it. Okay, because today also I have assumed that you understand the basics of databases. Okay, So that's the prior condition, Raju. Okay. So I know Java and R. Okay. Excellent patience I have seen as of now. So I did not get your question. You are saying that I have a great patience, or okay, great. So basically, yeah. So if you have Java and R, then it's good enough. All right. So yeah. So thank you guys, and I'm happy that you enjoyed the class, and it has actually extended 30 minutes above. In future, probably I will be going ahead and making it 3.5 hours class, and let's see how it goes. So feel free to get in touch with me in case you plan to go ahead with buying the full class. You can go ahead here and then you can attend. All right. And in case you have any doubt, okay, say for example, somebody was saying that we did not know that you had a cloud, or something like that. Just feel free to drop me an email, and even you can feel free to call me at my number. This is my number on the website itself. You will see the number. Okay, feel free to call me at this number in case you have any doubts. All right. So any other questions do you have, Raju? Guys, do you have any other questions to me? Great. Thank you, Raju, that you liked it. And yeah, I'll take a break now. And good night to you guys. Good night, Mohammed. Good night, Prashant. Good night, Devesh. Good night, Daniel. And did I miss out anything? Yeah. Okay. And good night, Sudhir. Good night, Aruna. Good night, Silpa. Good night, Manoj. Good night, Gaurinath. Good night, Tejvant. Good night, Brahma. Good night, Apaya, Shweta, Srinivas, and good night, Samar. Bye bye. Have a great day tomorrow. Yeah. So feel free to drop me an email or a phone. Thank you, Brahma. You liked the session, and I hope to do my job best. And in case there's a mistake, I'll try to rectify it. Yeah. Silpa, sure. I'll send you guys the presentation and the video. All right, but it might take maybe tomorrow evening time. All right. Thank you, guys. Good night. Good night. I'll disconnect the webinar now. Okay.